right. So hopefully you've read the abstract. I've just copied it straight from the website. But the idea of this workshop is to bring together researchers that are focusing on the healthcare space, well-being space, and in particular looking at how we can use XR technology. So that's AR and VR for those that are new to the area, and MR as well. But also there's a growing area of trying to apply AI to this kind of space. So there's some researchers that are focusing on that particular technique. Nutshell is, if you're working in the digital health space, focusing on healthcare and wellbeing, we welcome you to this workshop. There's hopefully some of you who don't have position papers but are coming to attend. We welcome you. So kia ora katoa, tēnā koutou, tēnā koutou. If we were not online, we would be in this place here called Christchurch in New Zealand. It's a beautiful place. It's nice and flat and it has lots of mountains. And if you ever get to go there, it's a fantastic place. It's about 45 minutes or an hour from where I'm currently at, in the middle of Middle Earth. They have a beautiful river that runs through the city, and they have this beautiful architecture, English style buildings. Unfortunately, due to some earthquakes about 10 years ago, some of the buildings are no longer there, but they're revitalizing the city, and it's becoming extremely vibrant. It's a great place to be. And you can see a couple of other pictures there of some of the harbours which are located on the other side of the city. It's where the HIT lab is, where Mark Billinghurst set up an amazing AR VR lab, and that's now being continued by a bunch of other people, notably Rob Lindeman. So some of the organisers of the workshop, I'm Craig. Helena's there. Do you want to say hello, Helena?
Hello.
And we have Joaquim from the University of Lisbon in Portugal. I believe Helena's in Europe and Joaquim is in Europe as well. And we also have Mark. I think Mark said he had to. Oh, are you there, Mark?
Good evening from Europe, and Mark will momentarily join us. He's ubiquitous.
Okay, cool. So we collectively some of us have been working together on a few projects over the years, and a last minute thought was, let's put a workshop together for VR. So Joaquim was planning to be in New Zealand at this time of the year, but not possible.
Oh, well.
And hopefully some of you would have loved to have come as well, but it is what it is. So today we have a little bit of a schedule plan. So we'd like to have a quick round of introductions and welcome. We thought that might take 15 minutes, but we're almost at that limit now. Followed by an invited speaker, Deborah Estrin, a professor at Cornell Tech. And Joaquim will introduce her a bit later. And then we'll have some position papers. And I think this will be the bit where everyone gets to have a bit of a chit chat about their projects. So we're aiming for like 3 minutes. Some of you can be a bit less. Maybe if you can be a little bit longer, but we've got about 16 keen lightning talks for the position papers. I've put all the proceedings online, so you should be able to see all the papers, and you can download them as a larger file as well. And by that time, it'll be a couple of hours once we finish them. So we thought we'd take a short break. If it's about that time, then that's great. If not, then no worries. If it's slightly later, that's okay too. And then we plan to have a couple of invited talks, one by Professor Philip Achenbolt from the McGill University, I believe, and he's going to talk to us about using VR for rehabilitation. And this is stemming from a previous workshop that was not proceeding through VR, and that's the connection with the other workshop for those that are coming to this workshop in addition. And then the final invited speaker will be James Hayes, who's actually from, based in Christchurch, but today he's actually coming in from San Francisco, and he has a startup around using virtual reality for medical coaching in the health space. Following those invited talks and speakers after the break, we'll have some breakout sessions based on a couple of topics that we've suggested, and we'll discuss those when we get there. So those are 4 or 5 topics. We may come up with some different ones, but we hope to go to a couple of breakout rooms and have a chat for about 45 minutes or something thereabouts, maybe an hour, and then we can come back and have a discussion and wrap up the workshop. And obviously that's a little bit longer than the workshop was intended to go according to the schedule. So if you need to break out and go to another workshop or something, you'll be most welcome, or go to sleep or whatever it is that you want to do. But those that want to hang around can come into the breakout sessions. Hopefully you can join us. Okay, so we have 16 position papers. I won't go through them all, but they are online. You can see the links and the papers. Joaquin will introduce our invited speaker. So there's the abstract online. So Professor Deborah Estrom will talk about immersive technologies for caregiving in the home, innovation opportunities and challenges. There's a paper similar to that into the workshop as well. And then the second speaker will be James Hayes, who will talk about how VR technology can enhance education and improve student outcomes. And James is coming from a teaching background into the startup. And then finally, Philippe will talk us through about the International Society for Virtual Rehabilitation. So we're looking forward to that short talk as well. Okay, so I make it 15:15. So why don't we have a quick set of introductions from everybody, and we'll give you 30 seconds. And if you just want to mention who you are, where you're from, and your sort of current research areas, just so that we feel that we're not doing Zoom fatigue and hearing just monotonous from everybody. So why don't we do that? I have a bunch of people online. So we've got about 30 people. So let's have a look at participants. So who would like to go? I could just randomly do it. So I could do it from my order and then I'll do it that way. Okay. So
Probably fastest if we do it by your order because it pops around.
Yeah. So I see Simon Kohler. Go for it.
Hi, I'm Simon Kleiber. I'm doing immersive analytics at the Graz University of Technology. And we've developed a system for ergonomics evaluation in VR.
Thanks. Paul Watson.
Hi there. I'm Paul. I'm a PhD student hoping to complete within the next month. I'm currently studying at the University of Plymouth. Yeah, and I'm interested in how we can apply theories of cognition to virtual reality design spaces to aid education.
Cool, thanks, Paul. Christoph Tucker, I don't know. Christopher, sorry.
Hi, I'm Chris. I'm a PhD candidate at the University of Kansas, and my research focuses on virtual reality for mental health and the remote treatment of depression and anxiety.
Cool, thank you. Carly, Wenda.
Hey, I'm Carly. I have my PhD in exercise psychology from the University of Georgia. So my work focuses on combining VR with exercise for improvements in mental health, and especially for things like chronic pain. And right now I work at Kessler Foundation in New Jersey, and I'm applying that research area to people with neurological disorders like traumatic brain injury and multiple sclerosis.
Cool, thanks, Carly. Marina Medeiros.
Hi, I'm Marina. I work at VR-based Research Center in Austria. I'm a PhD student also at TU Wien. My research interests are usually interaction patterns and techniques, but we have a lot of projects related to health in our institute. So I'm here to see what's going on and what people are currently doing.
Cool, thank you. Mine Chelali. I'm sorry, I butchered your name.
That's fine. This is Amin Shelali, actually. I'm assistant professor at the University of Paris-Saclay in France, and I'm working on the design of interactions and interfaces for surgical simulators.
Okay. Jawan Seo. Yeah. Okay.
Yeah. Hello. I'm Jawan. I'm a PhD student at UMBC, and my main research interest is related to the supporting the communication and collaboration with the XR technologies.
Great, thank you. Haroldson, I think. Thanks.
Hi, I'm Harold. I'm the director of the XR Collaboratory at Cornell Tech. I work with our master students there on a variety of XR-related projects, and I also teach 2 courses on AR/VR to our grad students.
Thank you. Catalina Morera, I think.
Hello, my name is Katerina. I'm a senior lecturer at the Queensland University of Technology. My research interests are the application of explainable AI techniques for enhanced decision-making.
Great, thank you. Norina Castella, I don't know how to pronounce your last name, sorry.
It's fine. Hi, I'm Norina. I'm actually from the University of Auckland, but I'm currently doing my PhD at the University of Manchester in the UK. And my topic looks at upskilling care home workers in hand hygiene practices using extended reality.
Cool, great, kia ora. Sarah EOM?
Hi, yeah. Hi, my name is Sarah. I'm a PhD student from Duke University, and I'm working on integration of AR for surgical application, specifically targeting the neurosurgeries for now.
Great, thank you. Love Coley, I'm not sure if that's right.
No, that's pretty good. I'm Love Coley. I work for a small medical software company that spun out of Professor Henry Fuchs's lab, medical augmented reality lab at UNC Chapel Hill. And we make a needle navigation system using ultrasound that's being used in hospitals today to help doctors get needles into targets to treat tumors and uterine fibroids and that sort of thing.
Cool, thank you. Mohan Zalaki, I think, maybe.
Hey, I'm Mohan Zalaki. I'm a PhD candidate from University of Florida. And my research focuses on using virtual humans to influence people's behavior using behavior change interventions.
Cool, thank you. Guillermo Carbonello.
Yeah, hi, thank you. Yeah, my name is Guillermo. I work at the Hanover University of Applied Science in Germany, and I work on a research project developing a mixed reality training for paramedics and emergency nurses. Thank you for being here.
Cool, thank you. Nastaran. Okay, cool, thanks. You're just on mute. If you just go on mute. Just that again.
Sorry.
Thanks.
Hi, my name is Nasan. I'm a PhD student from Victoria University of Wellington, and I'm working on the long-term benefits of augmented reality on organizations.
Okay, great. Welcome. Maximilian Reitinger?
Yes, hello. My name is Maximilian, and I'm a PhD candidate at the Technical University of Munich. And my research is about training in extended reality.
Okay, great, thank you. Lucy Cruiser.
Hi, I'm Lucy. I am a PhD student at the University of Hamburg, and I am focusing on cognitive physical training for older adults with dementia.
Okay, great, thank you. Regis Copper? Regis?
Yes, hi. I'm sorry, just have kids. I'm Regis Copper, and I am an assistant professor at the University of North Carolina at Greensboro. And I work with user experience in extended reality interfaces and applied. I do applied research as well.
Thank you. Alana Din. Sorry, oh, that one's changed.
That's right, you got it right.
Oh, yeah,
Hi, my name is Alana. I'm a medical student from Weill Cornell Medicine, and I'm working on research projects with Cornell Tech, actually with Deborah here, focusing on AR technology and telemedicine, specifically perceptions that emergency providers may have about it, as well as current teleguidance programs being used, both in interventional, educational, and diagnostic settings. Nice to meet everyone.
Okay, great. Something changed on my screen, but I think I've got up to the next one. Vutia Chinyang.
Hi, everyone. Yeah, I am Vutia Chiang. I'm a part of virtual and augmented reality group of University of Magdeburg. My research focuses on collaborative VR for laparoscopic liver surgery training and planning. Nice to be here. Thank you.
Great, thank you. Next up is Sanobada. I think I got that wrong, but sorry.
No, that's absolutely correct. Hi, I'm Sanova, and I'm a PhD student here at Aston University in the UK. And my research focuses on human to virtual human interaction. More specifically, I'm looking at if virtual human can kind of have influence a human user to have the same physiological response as does another human being. So that's kind of in a nutshell. Thank you.
Okay, great, thank you. Kaimeng Tang. Kimeng.
Yep, Kimeng, you got it right. Hi, I'm Kimeng. I'm a PhD student from KU Leuven, Belgium. In my research, I explore the potential of virtual reality and other playful simulation in supporting antenatal education.
Okay, great, thank you. Nisao Udawata.
Hey, I'm a PhD student in Victoria Institute of Wellington, and my research is about using XR for cardiac surgeries.
Thanks, Nisa. Pedro Belchio.
Oh yeah, hi, Pedro Belchio. I'm a master's student from the University of Lisbon, and my interests are in XR applied to medical imaging analysis, digital anatomy, and education. Hi.
Okay, great, thank you. Soo Young Yu.
Hi everyone, my name is Soo Young. I'm a research fellow at the University of College London, and my research focus on applying AI in the surgical context.
Okay, thank you. Yao Antonio Pereira.
Hi, I'm João Pereira from Lisbon, Technical University of Lisbon. Currently, I'm a workshop chair, and I'm here not only just to monitor this workshop, but also I'm co-author some of the papers on this workshop. So of course, I'm very interested to participate. Thank you.
Thanks, and sorry for switching over to the Zoom channel. We had some difficulties at the beginning, so.
Yeah. Okay.
Thank you. Stephanie Crow.
Hi everyone, my name's Stephanie. I'm a product design PhD student at the University of Canterbury in Christchurch, but I'm currently in Scotland, so hopefully I will see the nice pictures you showed at the start soon. My research is looking at generally VR and games and how they can help in the rehab of people with brain injuries.
Great, thanks Stephanie. Byron Perez Gutermer. Byron. Okay, maybe he's on mute. He doesn't have a picture. Okay, we can come back to him. Anderson, Michael, your camera was on just a second ago. Okay.
Hello, Anderson Maciel. Thank you. I'm an associate professor at the Federal University of Rio Grande do Sul, Brazil, and I'm currently a visiting professor in the University of Lisbon. And among several other things in VR and surgery, I've just submitted a proposal called Remote Collaboration in Virtual Environments for Surgery. So it's pretty in line with this workshop. Thanks.
Okay, great. Thanks, Anderson. Anthony Beug, B-U-E-U-G, sorry.
Hi, I'm Anthony. I'm from the University of Regina in Canada, working on mixed reality applications with computer vision.
Great, thanks, Anthony. Miriam Chipana.
Hi, my name is Miriam. So I am a PhD student in the HIT Lab, New Zealand. I just started. So my research is now in awareness levels in collaborative environments for athletes.
Okay, great.
So, thank you.
Marine Algaia, A-L-L-G-A-I-E-R.
Yeah, hi. So I'm a PhD student at the University of Magdeburg, Germany, and my research is in the field of VR training for neurosurgeons.
Great, thank you. Simon Horman, who I believe is coming in from Christchurch.
Correct.
Excellent. We have somebody.
Yes,
from
I'm Simon. Yeah, I'm from Christchurch, New Zealand. I'm an academic in the games program here, and my research is in user experience for health and training applications.
Great, thank you, Simon. Okay, then James Hayes.
Hi. Yeah, apologies for not having a video on at the moment. I'm a little bit concerned about my presentation later because the internet connection here seems a little unstable, but we'll see how we go. So yeah, I work in a company called Virtual Medical Coaching, which we started about 6 years ago with the aim to enhance student training in the healthcare and allied health profession, just to make it more efficient and effective for what students are doing. And we use a variety of technology. I'll talk about that later on, more paradigms than technology, just to make training accountable and results orientated. So thanks very much for having me here.
Thanks, James. Then I'll hand it out. So then I'll introduce Deborah, wherever Deborah is.
I think you're about to hear enough from me, so
Excellent.
I'll introduce myself as part of that.
I thought you would say that. Fantastic. Then I'll hand it over to my co-organizers, Elena and Mark. You've got something to say.
Hello, everybody. Welcome. I'm Helena Mentis. I'm at the University of Maryland, Baltimore County. Normally, right now, I am in Copenhagen, Denmark, on sabbatical at University of Copenhagen. My work is has traditionally been in collaboration, telemedicine within surgery, particularly telementoring, and more recently, AR as a mechanism for remote instruction in surgery, as well as emergency medical services.
Oh, just before I go to Mark, there was one person that just joined, Poreria Banyadam. Would you like to introduce yourself? And Anthony, if I missed you. Okay, maybe not can hear, or maybe I'll mute. Okay, Mark, would you like to say something?
Great. So I'm Mark Billinghurst. I'm a professor at the University of South Australia and also the University of Auckland here in New Zealand. My research is mainly around using AR and VR to enhance collaboration and empathic computing, and we're starting to do some more work on using the technology to help with depression and with medical training as well.
Thanks, Mark. And I'll introduce myself because I forgot to do that properly. So I'm Craig Anslow from Victoria University of Wellington, and I do digital health as a research area, and in particular focusing on using XR to help support chronic pain, medical surgeries, and women in labour. And I was going to write a paper, but we have lots of papers for this workshop, so I chose not to do it and I ran out of time. So welcome everybody. I'd like to pass now on to our final keynote, our final organizer, Joachim George, who or I like to say is the person that got us into this mess. So off to you, Joachim, who's also one of the chairs for the conference too. So Joachim, take it away.
Well, thank you so much, Craig, for saying it's all my fault. Joachim George here, professor at the University of Lisbon. And guilty as charged probably. And I'm interested in VR collaboration and applications to minimally invasive surgery, among other things. And I was on that proposal with Anderson. And it's my privilege now to introduce our first invited speaker, Professor Deborah Estrin, who is at Cornell Tech, professor of computer science. She is the recipient of the 2022 IEEE John von Neumann Medal, and she's done lots of other things. She is an elected member of the National Academy of Engineering, the National Academy of Medicine, and was chosen as a 2019 Fellow of the MacArthur Foundation. And she's going to tell us about immersive technologies for caregiving in the home, innovation opportunities and challenges. And thank you so much for joining us, Deborah. This is fantastic.
My pleasure. Let's see if I have more success sharing my screen than I did getting on the Zoom. Is that working? Oh no, I didn't click share. Is that working? Are you seeing my slides?
Yes.
Yes, we are.
Awesome. Just as my son calls me on the telephone, not expecting me to be doing something on a Saturday afternoon. Hello, everybody. Audio, everything good? Okay, cool. So as I was preparing my slides, I decided that I'm really a newbie to extended reality. I'm old enough to not be a newbie at a bunch of other stuff. And so what I decided to do is spend more time on what I have been doing in digital health over the years, because there are some things from that that are perhaps useful as technologists sort of lumber our way into the healthcare domain. At least that's what I felt I did initially. And I will work my way towards the actual topic of XR for caregiving, which is a relatively new thing for me, inspired by my colleagues Serge Boulanger and Harold Haraldson, who introduced himself earlier. Great. So slide advanced. It's the last time I'll do my checking. Okay, cool. I'm assuming if something goes wonky, somebody will unmute and just say something to me, because I'm not watching the chat. Okay, so this is a slide that I put together a long time ago, and I would add to it sort of for these keynotes, because keynote speakers are usually invited as much for their history as for what their present is. I had a wonderful colleague, Gaetano Borriello of University of Washington, who unfortunately passed away a number of years ago, but he used to say that he knew he had sort of made it when he was invited to give keynotes at the conferences that rejected his papers. So that's sort of the status of keynote givers. So let me give you a sense of sort of what I represent playfully here, of where I came from, because that informs what I'm doing now. So I started out of grad school at MIT a long time ago as an internet protocol, sort of internet architecture person, working on things like interdomain routing and network security and multicast routing. And I was sort of doing all of that before there was even the web, let alone Facebook and Google. But it was an amazing time, and definitely framed the work that I've chosen to do since then, in terms of being interested in things that are very collaborative, very experimental, and interested in taking a modular architecture approach to things and doing things with open source and open architecture whenever we can. I wandered from there about a dozen years after that into what we sometimes call distributed sensing or sensor networks. I did that in part because the internet was getting so commercialized at the time that it was really hard to do experimental things anymore. It was infrastructure that was critical to organizations, and they weren't interested in just, deploying things like multicast routing with a whole bunch of without a lot of careful preliminary work. So I moved into distributed sensing, sort of the predecessor of Internet of Things, thinking there was more room for exploration and looking at this, at the sort of algorithms, architectures, and protocols needed to make sensing work. And that work brought me really up close and personal with applications and mission-inspired work. Before then, I had been a internet protocol developer that was well below the applications that sat on top of us. But when you get to sensing, you really have to engage with what the data are being used for. And so I started working with environmental engineers and ecologists and such, and explored broadly the use of sensing and mobile sensing. And then once smartphones became a programmable around the mid-2000s, I started moving from sort of ecosystem monitoring to human system monitoring, and eventually digital health sort of emerged as my killer app. Yes, ironic term, which is where my talk will actually sort of start. And I want to spend the first few slides sharing my perspective on patient-centric technologies in healthcare, which is more the domain that I've been interested in. In other words, for use outside of hospitals, clinics, and labs. And then I'll segue to technologies for caregiving and opportunities for extended reality in particular. So my health-related interest has always been, as I was saying, in patient-centric technologies and uses outside of mainframe healthcare, a term that Eric Dishman, who was in Intel at the time, was the first person I heard mention that concept. And in particular, started looking at the use of patient-generated data to serve, if you will, the three feedback loops of health. So patient-generated data can be a powerful and scalable way to measure individual patient status and their response to treatment. And that data can serve as feedback to the clinician about changes in patients' experience, symptoms, and side effects. This is particularly valuable when clinical encounters are sparse relative to the course of the condition, so that then the value of high fidelity and high temporal resolution observability is really high. And that can be in chronic conditions from rheumatoid arthritis to diabetes and depression, or it can be for recovery from specific interventions such as surgery. So I sometimes refer to these as sort of patient-generated longitudinal N-of-1 data, and explored for a number of years how they can inform clinicians in their prescribing and titration of treatment, and also how patients can use these data to manage and to encourage their adherence to clinical recommendations. So early work addressed technical research challenges, activity classifiers and sensor fusion, time series analysis, getting things working on resource-constrained devices, privacy and security, as well as early work focused on clinical conditions where there was really the most need for these kind of data to improve care. So I talked about this back in a 2013 TEDMed talk. The TEDMed handlers that I had who coached me through giving that 12-minute experience, or 11 minutes and 47 seconds, it says here, they thought the term small data was a bit catchier than patient-generated data, not surprising. And so then in 2013, I spoke about one of the things that motivated me, again, TEDMed style, you have to start with a personal story. And so I started with an authentic personal story reflecting on my father's sudden decline during the last month or two of his life. Now, he was 90 years old and led a marvelous life. So this wasn't it wasn't so much that if only we'd known, but it was an experience that when I brought him into the emergency room, we didn't know he had been in fine health for a 90-year-old. The emergency room doctor did not think that there was anything unusual going on because my father presented very well for a typical 90-year-old. And yet I knew, of course, that this was not at all typical for him. This was very different from how he was behaving a month before. And at the time I reflected in retrospect that his sudden decline would have been observable in his digital traces or his small data, his reduced range and frequency of daily walks, shopping for prepared foods. And I wondered if maybe that well-being but very busy ER doctor would have found sort of a digital pulse computed on my father's small data more convincing or interpretable than he found me. So moving forward and around that time, looking at how to make digital traces relevant to clinical care is where I learned a lot about this process, and also learned a lot of humility, I hope. Initially, and at that time, it seemed like this is obvious. This can transform how clinicians care for patients. This can allow them to observe symptoms and process that was just previously unobservable to them. But of course, the story is more complicated. Health is much more complicated. Healthcare is much more complicated. And it's really a process that has to happen where you go from the raw patient-generated health data that the consumer technology is enabling through a process of defining what are actually the digital biomarkers that clinicians can process and respond to. And those digital biomarkers need to be validated before they can actually be integrated into clinical workflow. And they need to do that in order to actually improve rather than increase clinician burden in treating patients. Moreover, you need to validate those digital biomarkers in the context of specific clinical conditions and populations. So changes in mobility patterns mean something different for a patient who's managing dementia than somebody who's managing depression or surgical recovery. And the efficacy of using these digital biomarkers in care actually has to be done through even things like clinical trials. And you have to see, does it actually help to achieve tighter control and better long-term outcomes? And then also the measures themselves are highly personalized to each individual. We all have different baseline behaviors. And this is an interesting place where the machine learning techniques of activity classifiers and then those personal digital biomarkers really need to borrow from the kinds of personalization we do see in consumer technologies, from from keyboards to content recommendations. So I'm mentioning all of this because as we proceed with extended reality applications in this context, we are motivated as technologists and excited by that, by the huge potential. And we also have to have a certain amount of patience and diligence in working through what it's going to take to make these technologies actually useful in care. And while we know and believe that they are very generalizable, care itself is siloed and very specific, you know, orthopedics from gynecology, depression from more serious mental illness, and all of those, and in each of those subdisciplines, we have to walk through the process that those clinical disciplines need in order to bring these technologies into their workflow. So we made most progress, not just we, the community made much progress in digital health by focusing first on digital biomarkers that enable more continuous out of clinical observability of established measurements. We didn't go and say, you're going to discover entirely new behavioral biomarkers by collecting this data initially. Rather, we went for things like the tapping test that's used for Parkinson's, the 6-minute walk that's used for various conditions or in cardiac rehab. So sometimes, again, our goals are that we can really change the way medicine is done entirely, but we probably have to start out by augmenting and improving the way medicine is done now. So one of the things that that community has also done, whoops, sorry, I'm forwarding on the wrong display. There we go. So in that process of going through and developing digital biomarkers out of patient-generated data and moving it into something that can be used in clinical care. Another step in that process is moving from digital biomarkers to digital therapeutics. And you've seen that in the industry and you see it in research. So in some clinical contexts, we can advance from just the measurement through digital biomarkers to actually digitally enabled treatment, otherwise known as digital therapeutics, where the treatment itself is delivered via the digital technology. And we see in digital therapeutics that mental health and musculoskeletal health are some of the earliest opportunities where there have been opportunities to really fill gaps that are in existing clinical care and bring these things into care. So I heard from a couple of folks who were introducing themselves. Maybe I was just biased towards hearing that many are looking at things related to mental health, and there are also things related to rehabilitation. So musculoskeletal treatment, prehab, what you can do before surgery to help in your outcomes, rehab, are key examples of early adoption contexts for digital therapeutics. And really clearly, there's a lot of power within these contexts of mental health and musculoskeletal health. There's also far more generalizability at the same time that not all therapies and therapeutics will end up being delivered digitally, obviously. So just a comment here on this sort of term we often use as technologists about low-hanging fruit, that sometimes that term is used to point to opportunity. Sometimes we're sort of chided for it, that we're being too opportunistic, that we're sort of looking for the keys under the lamppost. And I have to say that in this context, it's hard enough to do things that can help in health and healthcare. And I think it is, in fact, just absolutely the right strategy to go to those contexts that feel like the low-hanging fruit, that look like the opportunities that we can make most progress on right away, that it's not a cop-out, it's actually a very effective strategy for both having an impact in the health context and advancing the state of the technology. Then as you go and move it on to other domains, other contexts for healthcare, the technology itself will be more mature. So finally, XR. Digital therapeutics is a growing use case for extended reality. And this is both leveraging advances on the consumer technology side and other applications that many of you are working in from the introductions having to do with clinical training and simulation. And again, and not surprisingly, both behavioral health, mental health, and physical therapy are really the early successes here, as well as excellent contexts in which to focus. So across patient-centric developments of the last decade, patient-generated data, digital biomarkers, and therapeutics, adoption has been much slower than I certainly naively anticipated it to be back in the sort of late 2000s when I started, and certainly, 2012, 13, I still thought that it was close to really happening. Now, granted, I am from the US, I operate in the US, and our healthcare system is particularly peculiar and particularly complex, and not very rational. So introducing technologies that help with prevention, that help to minimize acute care, are not necessarily the first to be taken up in the market and in care. I've said before that irrational healthcare systems do not incentivize rational technologies. So, but even here and in the US, I think there is now reason for accelerated demand that's come about in the context of virtual care. Obviously, the last 2 years of the pandemic. By the way, my background is from New Zealand, and it's the last sort of serious international trip I took just before the pandemic, having been there from sort of the turnover from 2019 to 2020 in a camper van. Can't recommend it highly enough. Very disappointed that I'm stuck here on Zoom in New York City. Anyway, so the pandemic in the US pushed through adoption of virtual care. How? Not only because patients wanted it, but because insurance started reimbursing clinicians for delivery of care over virtual technologies. The platforms have been around for for decades, as we all know, but it's that demand for containing infection and then availability of reimbursement that really changed the game. So, but within virtual care, clinicians are expected to diagnose and treat and manage disease with greatly reduced signals relative to having a patient in your clinic. So virtual care might really be the context in which patient-centered technologies come into broader use. Because it addresses the needs of clinicians, not just patients. And at least in the US, technology is adopted into healthcare when it solves clinicians' needs, for better or worse, not so much just driven off of when it's solving patients' needs. So note in this illustration, I included a person sitting next to the patient, to the left of the patient, as sort of the caregiver. And as I mentioned before, 15 years ago when I started doing digital health, I was motivated to address tech for aging since my parents were then in their 80s. However, even though they both had PhDs in electrical engineering, introducing new technology for their independent use as patients largely failed, and I tried. And so I sort of wandered off to focus on the use of mobile technology, mobile health, and digital health for more digitally native populations. In contrast, my real medical doctor sister used the really common tools of the time, telephone, email, and fax to engage not my parents themselves, but my parents' caregivers. First, my father as my mother's primary caregiver, and after he passed, a professional home health aide. So while many products are direct to patient, I'm particularly interested in the opportunities of developing technologies for caregivers. And we heard that from some of you in the audience as well. So I'm finally, in the last slides of my talk, getting to the topic that had been advertised to you. And once again, give me 1 second, I'm forwarding on the wrong slide. Okay, so why tech for caregivers? First, demand. So while home-based healthcare is, yes, a mainstay, particularly since the COVID pandemic hit, and the need for at-home care long predates all of that. You look at the worldwide aging population and the burden of chronic conditions from diabetes and cancer to heart disease and dementia and clearly mental health. And the statistics on aging population and the need for caregiving are both a challenge and for us, I think, in this community, an opportunity. So second of all, home care really matters, okay? People with cardiovascular disease, metabolic conditions, cancer survivors often need assistance to adhere to their medical regimen, a medical regimen that's changing all the time. Medications, exercises, vital signs, post-surgical treatment of wounds. And the lack of attention to an issue early on can contribute to otherwise avoidable health declines and medical bills. So that's number two. Number three, the work of caregiving is difficult and complex. Caregivers put in long hours, whether it's a family member caring or a home health aide. And they engage in a range of work from very routine and repetitive to the unusual and urgent. And at the same time, care work is undervalued, at least in this country, undercompensated and underinvested in, particularly in terms of training and tools. Also, as a gerontologist researcher, I was working with at one point a professor of neurology at Oregon Health Sciences University, Hiroko Dodge, once pointed out to me, differentiation increases with age. So patient care paths vary significantly across individuals once you're dealing with older adults. Babies are basically very similar to one another other than their genetic makeup, whereas by the time you're 80 years old, your presentation of disease is very difficult. So it's very difficult for a caregiver to be a priori trained in all the range of things that they're going to have to deal with. In this work, and I think for many of us, the preferred vision then in supporting caregiving is actually to bring superpowers to human caregivers by augmenting those caregivers rather than by replacing them. And so we've been looking at intentionally developing technologies that support aging in place, but not aging alone, and that upskill rather than descale professional care work, to allowing care workers in the home to do more than they currently do because of the possibilities of extended reality to help them do those more difficult tasks, those tasks that they hadn't been pre-trained in. So we're particularly focused on those episodes of acute need for support on physical medical tasks of caregiving. So you're going to hear more about this work from Harold in his 3 minutes a little bit later, but let me give you the high level pitch. So finally, XR in caregiving. Consider this aspirational illustration of an immersive care system of the future. On the left is a caregiver assisting, for example, a breast cancer patient recovering from surgery at home. The caregiver has reached out to a clinical expert, that expert's on the right, to determine if the patient's sudden lack of progress in their mobility exercises is a cause for concern, and if they should adjust the physical therapy regimen somehow, or if the patient needs to come in for an in-person exam. The remote expert on the right is there to help assess and give feedback. And in the more distant future, it might well be that an AI agent would be able to observe in order to provide guidance in future repetitions of the task. The clinician in our model of this uses virtual reality to view details as if they were in the room and to instruct the caregiver on adjustments in perspective or pose. And the clinician's guidance is communicated to the caregiver on the left through augmented reality, in this case, head-mounted display, providing detailed visual information overlaid onto the caregiver's view of the patient's torso or limbs. And then in subsequent repetitions of the exercises, that future agent-enhanced XR system would be able to support the caregiver in repeating the procedures. That's the long-term vision. We're far from being there. Beyond this rehab example, this would allow remote experts to provide guidance on a range of emergent care needs, whether it's assessing lower limb swelling for heart failure patients, labored breathing, changing dressings on an incision site, assessing and assisting patients post-surgery with balance and mobility, administering IVs, or other kinds of injection-based therapy. All of these things can be really daunting if you've ever been in a position of particularly dealing with a family caregiver, as a family caregiver for a loved one, as well as for aides who have not had specialized training. So to get started on this aspiration, on this vision, we developed a prototype this past summer using off-the-shelf hardware and software platforms. This slide shows our lab setting where we are working to advance the research, and it's set up based on using Microsoft HoloLens, Connect platforms, in that simulated home context of the patient and the caregiver, and Oculus Quest for the remote clinician in the simulated clinical setting. And like I said, we'll hear more from Harold a bit later. But to give you a sense of what we're doing, here's an example of an edema test. Heart failure patients have issues with retaining water, and home caregivers need to check if they see swelling in the leg or the ankle. If that's a clear indication of water retention. There's something called an edema pitting test that is done. And in this somewhat dizzying for simultaneous screen picture, you see the local view and the remote view through the extended reality, and then what's actually going on in the scene in both those contexts. We have the point of view camera feed from the HoloLens, and we're supporting and exploring interaction techniques, including gesturing and annotations. One of the things that we expect is going to be very compelling, and as we speak with more clinicians in this context, is not only the ability to annotate, but also the ability to annotate and capture, and then look at the current state in reference to prior annotations. That ability, that's really something that goes beyond just what could be done in person in the clinic now, to really extend beyond current approaches and improve on that kind of interaction. Across sort of bringing all of this together and to extend beyond what the state-of-the-art out-of-the-box platforms can do, we roughly characterize sort of research challenges into things related to interactivity. So both qualitative and more detailed interaction technique works in the context of HCI. The whole slew of computer vision and graphics related challenges to really make this work well. Our current prototype, you will notice more things that seem to be not working well than work well. The ability to actually register annotations on the complex shape that the human body is, and to have those registrations work no matter where somebody would move that particular limb, let alone to move on to the ability to use projection technologies and such. And then eventually, as I mentioned, the opportunity to have agents do agent learning and be able to help when that live synchronous human expert is not available. Coming to the end, this is a topic in which values must be part of our design from the outset. So I think that from the perspective of saying that I want to bring superpowers to caregivers, rather than having individual age alone, that by itself is in a sense, a bringing a value to our design. So trying to both promote the aging at home and the human contact, and also, second of all, to promote the caregiver, to give them more agency to work to upskill what it is that they do rather than to eliminate them. And also, as we do this, we're talking about bringing technology into the most intimate context that we have in the home and into our most intimate moments as we are frail or recovering and vulnerable. So all of this demands a values perspective from the outset. So finally, and just to summarize, caregiving in the home is important and poses interesting technical challenges for augmented intelligence researchers, ones that are both difficult and likely, and yet at the same time tractable because of the structured nature of many of our important care tasks. So in this work, we've gone to tasks that already need to be done. We're not trying to do something that isn't a part of healthcare, and we're focusing on physical care tasks that are well-defined and that exist in the literature that people are trained to do, and that we can then bring on our extended reality technologies to augment. We hope that advances in immersive care technologies will help to catalyze a transformation in caregiving to support aging with integrity, And if done right, this could really enhance the lives of both aging adults and the people who care for them. And doing it right really calls for a multidisciplinary collaboration from the technical side with all the stakeholders in the room, in the conversation, clinicians, patients, and caregivers. It's a messy problem. It's one that will likely require academic and public health lens to drive it. And that's one of the reasons that I find it very interesting. I think that eventually, there's no question this will bleed out and be pursued in the commercial sector. But this framing of technology and supportive caregiving is one that's a little too messy, a little hard to capture value initially in the context of commercial startups and products from the get-go. So from that perspective as well, I think it's a very interesting one for those of us in the research and context to pursue. And with that, I'll complete.
Okay, thank you so much for this inspirational talk. Wow, we got 49 people now, and that's exciting. I think we have time for some Q&A. So you are welcome to place questions either here on Slack or on Zoom chat, and I'll be happy to convey them to Deborah Estrin. Or you can ask them directly.
There's nothing worse than giving a talk without a single question.
Okay.
Well, there are many things worse, excuse me. When you're giving a talk, one of the worst things is not having a question.
Well, you talked about small data, and everybody talks about big data these days, and I guess you made the point here. Is small data important other in the context of self-care at home? I don't know if this question makes much sense outside the context of patients being able to give their data to remote physicians, but you also need that other big data, the clinical history of the patient, etc. How do those interplay, and how do you see that working with respect for privacy in this dangerous world that we are living in?
So I asked for a question. You gave me a very big question. So I'll just try to keep it brief. So to the extent you're giving, privacy is an interesting term. I think I follow the school of thought of Helen Nissenbaum, who has a whole contextual integrity theory of privacy, which is that data by themselves don't have privacy associated with them. It's the data flows, who uses them and for what. In clinical care, as you mentioned, we give very private information to our clinicians because we both trust them and they are regulated and required to act in a certain way with those data. And the same, I think, is proving to be true as we pursue mobile health data, wearable data, and such. The fact that people give those data to large tech companies under terms of service that, at least in the US, are insufficiently governed, maybe the world is evolving to improve in that perspective as well. But the use of those data by your clinician and by your clinical care system is not the point at which I see the privacy problem. Okay. So, and then just to add, all of these data are only relevant in the context of standard clinical data. We see it most relevant. For example, we're starting to see more and more of things along these lines in the context of behavioral health. So both for serious mental illness and depression, there are products out there that provide these type of longitudinal N of 1 data to help processed into something more like a digital biomarker to inform treatment and titration of medication by the clinician.
Okay, thank you for your answer. When working with caregivers remotely, what information do you use currently other than audiovisual data? This comes from Mohan Zalaki.
So that you asked a question in the present tense, what data are already used? So it's very variable, but even, Epic is the dominant electronic health record in the US. And within Epic, some Epic deployments, patients can already upload some digital biomarkers or biometrics from something as classic as, for example, a blood pressure cuff to something from their wearable. And so that is the very slow path by which this is starting to actually be seen in use, perhaps more in cardiology, more in behavioral health as some of the earliest of the adopters.
Okay. I have another question that intrigued me during your presentation regarding the rehabilitation. So if you made these sketches or so the physician is remotely assisting a patient, and if they do remote annotation on using the augmented reality projection that they see on the 2D version of their mobile or their flat screen at the clinic, how precise, isn't that the problem regarding rehabilitation? Because rehabilitation movements have to be done in 3D. We have done some research in that area. We have focused on spatial augmented reality and how we could convey the information in 3 dimensions. My question is, have you looked into this?
You're 100% right? If that, and we've done no particular work nor made progress in the context of how do you make this work in sort of in quasi 3D. We've just been trying, almost more focused on the augmented reality side, and just linked into saying, for right now, assume that that a clinician has the ability to see in 3D, which right now happens by them putting on a VR headset, which I don't think is the long-term broad way in which all of this will happen. But it's the way we can sort of, the way we can scaffold the work while we try to make progress on the AR side. So I think it's an excellent question for which I expect some of the other people in the workshop perhaps have answers, but I do not. You can ask that question of Harold later.
Okay, will do.
Guillermo, you have your hand up?
Yes.
Sorry?
Yes, thank you very much. Yeah, I have a question. Thank you very much for your presentation. It was very interesting. Your future vision about the XR supported caregiving is very, very interesting. And I think it is also quite complex. And sometimes we even have problems in, I don't know, like playing the microphone here correctly or putting the camera on Zoom. And with this very complicated multimodal XR future that you envision, do you see any problems with that, taking into consideration that majority of people is not that technical savvy?
So 100%, but I'm trying to get rid of the word, not use the word but in my vocabulary. However, we want to progress, and I think most of the people in this community are technologists. We're trying to advance. You can't advance everything at the same time. You're trying to advance progress in one particular thing. And so we're, for example, trying to make that AR, there's, just as I answered about okay, I know it's not the reality for clinicians to walk around with VR headsets on, but for the sake of making progress in this, I'm going to effectively sort of simulate. Similarly, it's going to take a lot of careful usability work by the time we get the underlying technology out there to make this stuff deployable and usable. And that kind of multi-stakeholder perspective is a great sort of HCI work to do in an exploratory way to understand what those limits are, but it's almost premature to do right now because the core technology that you want to get working isn't even working. And so, look, in the old days, it was much more complicated to get on a Zoom than it is now. Okay, when people changed the Zoom login process for you, you know, a day before you're joining. I'm teasing you guys, teasing, joke, sense of humor. You know, it makes it more difficult, but we can all get on Zoom with more facility than you know, a lot of the world can than just 2 years ago. So I'm not dismissing those issues. I'm just saying we haven't, yes, unless all this stuff is made more sort of out of the box usable, that will be a non-starter. But I don't think it's the long pole in the tent in terms of what's going to take the most time to fix.
Thank you.
That remark of yours, Deborah, begs the usual joke about technology impaired meetings, and I totally agree with you. Technology sometimes can be quite an obstacle here, and it would be fun if sometimes we don't feel like crying. With all that said, anybody who has a last question?
Love has his hands up.
Yeah, thank you for the great talk. I have a question sort of about continuity of care. It's often the case patients will go from hospital to skilled nursing facility to home health care, and during every transition, some information is lost. And you talked a bit about things like annotations to help with that transition. I'm curious if there are other technology areas where we might help prevent that information loss on each transition, and whether you've also seen cultural challenges in integrating this technology, because, you know, a lot of times in the medical profession, it's very hard to find the time to explain all the nuances of care to the next transition or to the next level of care.
I think that question just stands by itself as sort of an important question. You know, we increasingly don't have skilled nursing facilities or insurance that gets anybody there, right? People are in the hospital for as short a time as possible and get sent home. But nevertheless, all those transitions are problematic. Information is lost. The family member who's taking the person home from the hospital is extremely stressed, and they're given a whole bunch of instructions and pieces of papers or links to things on the web. And when you get home and you're dealing with something, translating is very difficult. So I have two things to say. One is I think there's a lot of opportunity to try to do better, capturing data, making it visible at various points for that issue of continuity of care. I would say in this country, we don't even do the most basic thing, let alone, but by the time we get all this stuff working and usable, I would hope that it could follow a more regimented path of other type of data that is finally moving as part of a continuity of care. And just the other thing I wanted to say is no matter what was done somewhere else and you're in a new context, I think we're going to need the ability to reach out to a remote expert and get help, because it's hard to translate what was done there into what's going on now. So we want a combination of data that follows, but also the ability to reach out for that in the way that extended reality can bring that kind of collaboration at a distance.
Thank you.
Okay. Thank you so much for this inspirational talk, Deborah, and I hope that you got enough questions to your content. And,
thank you very much, and thank you for inviting me.
Well, thank you for accepting the invitation. This was fantastic. And please join me in thanking Professor Estring for a fantastic talk. And now I would yield on to Craig for the round of lightning talks. We have 16 33-minute slots. Craig, over to you.
Thanks, Deborah. Much appreciated. Come back and see us. We have lots of camper vans. So thank you very much, everybody. And so now we transition to this lightning talks for the position papers. So we have 16 talks, position papers, and I thought we'd do 3 minutes each, which will give us about 48 minutes. And so that'll give us to just after 10 o'clock. So if you could be no more than 3 minutes, that would be very much appreciated. And the idea is the position papers will then form the breakout sessions later on. So we've got some potential topics. But first up, thank you very much, everybody, for submitting a position paper. Thank you for putting into the camera ready instructions. I know there's a lot of confusion, but it was really much appreciated. So Helena and I are going to probably try and somehow manage this on mine and with a timer. So we'll just go from 1 to 16 based on the website. And those were basically papers that were just came straight from the submission system PCS. So there's no specific order. And so I didn't group them at all. So does that sound like a plan for everybody? 3 minutes, I'll put a timer on here. And if you've got questions, Helena can manage the chat and I'll manage the...
I was just about to say that if you don't know when your talk is or anything like that, or you're just not sure, send me a message in chat and I'll get you on the right path.
And
hopefully everybody is able to share their screen.
Yeah, I've got set it to multiple screen. And a bunch of people have joined us recently. But if everybody could do a quick welcome inside of Slack, just post your name and your URL or any links that you have specifically about these position papers. The position papers are linked online and the proceedings are there as well. Okay, does that sound about right? We won't take any questions. We'll leave that for the breakout sessions, just because we'd like to get through as many and like to hear from as many people as possible. Okay, so without further ado, we'll go to paper number 1, the virtual human breathing coach by Sanobar and Da and colleagues. Sanobar, are you ready?
Yes, hello. Yes, I'm ready. I will share my screen with you all.
All right.
Just bear with me.
Okay, go for it.
Can you see my screen?
Yeah.
Brilliant. Hello. My research explores human to virtual human interaction, and I want to investigate if a virtual human can influence a real human's physiology. Now, a human to virtual human interaction can be a stimulating experience where a virtual human can bring in a sense of personal connection, which is felt through the exchange of bodily cues. For example, when we interact with a human therapist, we not only follow their instruction, but also get influence from the physiology. Here, we are focusing on breathing physiology due to its relationship between physical and mental health. For this, we developed the virtual human breathing coach, which is a relaxation system based on breathing physiology. Here we have a realistic virtual human who speaks in human voice and also uses lip syncing. It also displays several gestures like pointing, nodding, etc., and most importantly, exhibits the breathing physiology. Our virtual human acts as a breathing coach, giving voice instructions to the user, and also displays the breathing movements to kind of influence the user, and it guides the user through a set of box breathing exercises. In our experimentation, participants complete 2 breathing exercises, one with a shorter inhale, hold, exhale breathing cycle, and one with a longer. The order was randomized. They also completed 2 post-exercise and 1 post-experiment questionnaire. The questionnaires were incorporated within the system and were completed in real time. The system runs seamlessly in the browser without the need to install anything. Here's a little demo. Overall execution, the breathing cycle, as well as the physiology, the animation, they were all controlled using finite state machines. Given that the system was running in the browser, one of the things that we wanted to investigate was how was the system run? And as you can see, majority of the people said it ran very well and they're willing to try the system again. In terms of the virtual coach, we wanted to find out some of the important qualities that a coach should have. For example, likability and trust. In our pilot, we found that people actually liked and trusted the coach. Participants also reported that the breathing exercise was easy to perform. Well, the main objective was to find out whether the virtual coach was able to influence the user. And as you can see, majority of the people said that they felt influence from the coach. Thank you very much. Yeah.
Very nice. Thank you very much.
All right. Thank you.
Simon? Sorry.
Ready, Simon? Where you going?
Can you see my screen?
Looks good.
Excellent. Hello guys, I'm Simon Kleiber, and today I'd like to present to you our immersive analytics system for ergonomic evaluation in virtual reality. Now, nowadays, ergonomic evaluation is very important for a modern workplace to keep workers' health up and to prevent musculoskeletal disorders. And together with the advances in virtual reality technology, we have been moving away from the pure simulation without a human in the loop. We've been able to integrate more interactive approaches into ergonomic evaluation. And this supports a more subjective evaluation, which often differs from a pure objective one without a human in the loop. Now, existing methods for this often use complex tracking methods, have analyses that are done outside of the virtual environment, and often do not provide any real-time feedback. And we have tried to alleviate this by first creating a virtual avatar with 5 tracking sensors. So we have 5 tracking sensors, and together with immersive kinematics, we can feed this virtual avatar in an established ergonomics evaluation system. And in addition, we're using Manus VR gloves for a more intuitive experience. This all feeds into an immersive analytics system that on the one hand provides real-time feedback, as you can see here, while you're performing a task. And on the other hand, we can have a replay of the session, and we can visualize in this replay the different results for ergonomics on the body parts based on our ergonomics evaluation. In addition, it's possible to filter for certain poses, for certain bad locations, so that you have a better overview of what happened and can see egregious locations. In addition, you can also have a heat map where you can see where users were moving and what weights they were carrying. In addition to this proposal, we have performed an expert interview to kind of get a different view on it. The expert found the accuracy of our avatar to be sufficient, albeit with some minor improvements. And she found the VR representation of the body very useful for a more holistic view of an evaluation, especially considering that she's mostly using videos, so 2-dimensional videos for her evaluation. And in today's world, of course, we have remote working, remote collaboration for ergonomic analysis. So to sum it up, we've created a virtual avatar that has an easy setup, and together with an ergonomics evaluation system, it feeds into our immersive analytics, where motion capture and motion exploration can happen in the same virtual environment. We also gave an expert view on our proposal, and for the future, we would like to use our system to compare different avatar tracking methods to ours and to compare different ergonomics evaluation systems. Thank you very much, and I'm very much looking forward to our discussions.
Great. Thank you, Simon. All right, up next is Katarina, I believe.
I'll do the presentation.
Okay, shocking.
Okay. Yeah.
The time starts now.
Just a second while I'm sharing my screen. Okay.
I'll pause it for you.
I'll share. And can you see my screen now?
Looks good.
Yeah.
Yes. Wrong presentation though. Okay, so it is the improving X-ray diagnostics through eye tracking and XR. This is work that Katarina and I are doing with 2 radiologists, that's Isabel Nobre, Sandra Costa Souza, and my colleague João Madeiras Pereira. And what do we propose? We propose that to use virtual reality for X-ray image diagnostics, and in the practice and with the potential of making machine learning understandable for radiologists. And how are we going about that? We are wanting to combine virtual reality with eye tracking technologies and human-centric artificial intelligence and explainable AI. Let me explain a little bit. So virtual reality in radiology rooms, we published a paper in 2017 in CAI about this called VROOM, which is the virtual, sorry, are you seeing the slides for my talk or
Yeah, we were seeing your talk for number 12, but I believe Katerina's, we were supposed to see them.
Wow, good catch.
Anatomy. Sorry, we're supposed to see
improving X-ray diagnostics.
Are you seeing now the, okay, my screen sharing is paused.
Yeah, we're just
We're
seeing.
watching design requirements to improve.
Oh, gosh. Oh, wait a minute. I know what happens. I will have to reshare again.
Okay.
Stop share. My apologies.
It's okay.
No, really good good catch there. I was like, okay, I'm watching this.
Thank you.
So I hope you are seeing now the right slides.
Yeah, that looks right.
Okay, so we presented room, and sorry about this. So the possibility for X-rays to use head-mounted displays in the reading room is that you can correct some of the features in the reading X-rays, ensuring correct lighting conditions, reducing visual fatigue, collect accurate eye tracking fixations, and the pupillary activity. And we think that this project presents an opportunity for learning and training for young radiologists. The interesting thing about eye tracking the pupillary activity is that they can provide insights into the terms of radiologists. On the three images that you can see on the bottom, you can see the eye tracking patterns for trained radiologists, students that eventually got the correct diagnostics, and students that did not know what they were doing. So interestingly enough, eye tracking is very much task-oriented, and you can learn a lot from the fixation patterns of people that look at X-rays, and you can use this to improve diagnostic purposes. So how do we go about human-centric AI and explainable AI? Well, the idea is that deep learning systems for diagnosis are very susceptible to bias, and they can make correct predictions, but A, not for the right clinical reasons, and B, the black box machines are very inept at explaining to radiologists what were the reasons behind the diagnostic. And the problem with explainability is that you can look at the patterns in machine-generated explanations, and the human expert highlights of diseases in lungs, in thoracic X-rays that diverge widely. And our hypothesis is that using fixation, eye gaze patterns, we can teach machines that can develop explainable models that radiologists can understand. So we argue that eye tracking and pupil dilations can contribute to novel human-centric AI, learning architectures that can learn from unit classification and can help us better explain how the machines make predictions. And thank you very much. Well, Katerina and I will be available to explain more about this in the breakout sessions.
Okay. Next up, we have Maximilian. Are you ready to go, Maximilian? On VR training, the unused opportunity to save lives during a pandemic. Are you ready, Maximilian?
Okay, can you stop sharing?
Oh, Maximilian, you're on mute, so just go on mute.
Oh, sorry, I was talking with can you see the screen? I prepared
just hold on a second. There you go. Yeah, it's just coming in now with some graphs.
Okay.
Yeah, are you ready?
So, enjoy.
Okay, go for it.
Hello everyone, my name is Maximilian Rettinger and I will present you a paper titled VR Training, the Unused Opportunity to Save Lives During a Pandemic. The mortality rate of patients in intensive care depends on the medical staff's experience. Especially during a pandemic, there may be an above average need for knowledge in a specific area. For example, the COVID-19 infection can damage the lungs and lead to acute lung failure. The last therapeutic option is extracorporeal membrane oxygenation, called ECMO, which fills the blood with oxygen outside the body when the lungs can no longer provide sufficient oxygen to the blood. To acquire the necessary experience for this therapy, a hospital department takes about 3 years and 50 treatments to gain the required experience for a successful ECMO treatment. Consequently, the mortality rate of ECMO patients was substantially higher during the pandemic than before. Due to the need and the various possibilities of the virtual reality technology, we developed a VR training application at the pandemic's beginning. Thereby, we initially focused on the priming of the ECMO machine. For this, we defined the training content based on the manufacturer's official manual and training video, which led to 41 different training steps. Then, we implemented the software that was designed to be cross-platform to reduce hardware-specific limitations as far as possible and enlarge global distribution of the application. For this reason, we also implemented the application in multiple languages. Previous results indicated that VR training can improve learning success more than conventional training or video training. So in order to obtain new findings for optimizing VR training, we provided the soft and hardware to several medical institutions and the medical device manufacturer. The resulting feedback was mainly positive. It was noted that the virtual environment is clearly arranged, the usability is simple after a few attempts, the respective steps are easy to learn, and the possibilities of the VR training are convincing. So overall, VR training provides a variety of possibilities and advantages that can influence the mortality rate during a pandemic. Therefore, we recommend the establishment of a worldwide network of experts who can bundle the relevant information and integrate them into a platform. This would allow medical professionals to train in a simple, flexible and standardized way. Thanks for your attention. If you have any questions, please feel free to contact me.
Great, thanks Maximilian. Perfect timing. Okay, up next is Pedro from Joaquim's group, and he's going to tell us about Anatomy Studio 2, a cross-reality application for teaching anatomy. Are you ready, Pedro? Okay, take it away.
You are on mute, Pedro.
Yes, I was. Just a moment. Sorry about this. Can you see my slides perfectly?
Yes.
Yeah. Okay, let's go. So this is a presentation for Anatomy Studio 2, collaborative remote teaching of digital anatomy. Over the past decade, universities have seen a strong push towards remote learning with a growing offering of online courses. Now pushed by the pandemic, climate change events, and even armed conflicts, the demand for remote learning tools has never been greater. 3 years ago, we produced Anatomy Studio, an augmented reality tool for collaborative digital anatomy. It allowed multiple users in the same physical space to share a virtual 3D canvas where they could recreate anatomical volumes. Now we are working on Anatomy Studio 2, a cross-reality remote collaboration tool for teaching digital anatomy. Using a desktop, mobile, or VR client, students and teachers can connect to a virtual classroom to participate in digital anatomy classes. In this virtual classroom, teachers and students are represented by digital avatars. Each avatar is colored with a unique color that is part of a color coding system that supports collaborative work. At the heart of digital anatomy classes are the datasets. These datasets are stacks of anatomical axial images, such as those from the Visible Human project. In our virtual classroom, the dataset is pre-selected by the teacher and can be navigated by interacting with a translucent, full-body 3D model that was recreated from that dataset. This model stands upright in the middle of the virtual classroom on a circular podium around which all the avatars are distributed. Students can select an image from the dataset by moving the model up and down using a vertical grab and drag motion with the top of the podium acting as a selection plane for the dataset. Users can also rotate the model by using a horizontal grab and drag gesture, and they can also scale the model up and down by using a two-handed pinch gesture. Teachers can switch their virtual classroom between one of two modes, lecture mode and exercise mode. In lecture mode, all of the teacher's actions are replicated in first-person perspective for each of the students. While in this state of passive observance, students are automatically muted. However, students wanting to pose questions can request to speak by raising their hand. The teacher can then unmute the student, making their avatar visible and audible to the entire classroom. In exercise mode, the virtual classroom groups students up in pairs or threes, and voice communication is active between members of the same group. Students can request the teacher's presence in the same way as in the lecture mode, and the teacher can join any student group to either observe or to provide assistance. By selecting images from the dataset and drawing contours on them, either with the headset remote controllers or with their fingers, students can recreate the anatomical volumes for a large list of anatomical structures. These anatomical volumes appear in real time inside the full body model and are visible to all other members of the group, as well as having a color-coded outline. Additionally, horizontal colored lines on the full body model indicate which images are being used by which student at any given point. 2 or more students can even work on the same anatomical structure, but they cannot do so on the same image at the same time in order to prevent them from overwriting each other's work prematurely. While a student is contouring a structure on a given image, other students that are working on the same structure will see that image tinted with the first student's color. Our takeaways. We are working to increase awareness to facilitate cooperation. We do so by using more realistic avatars and distorted representations and by exaggerating gestures. We are also working with changes in perspective from first person to third person. There is a lot more to Anatomy Studio 2 than I could possibly speak here, so please look forward to hearing more from us in the future. Thank you very much.
Thanks, Pedro. All right, up next we have Vuthia, I believe it is, and towards virtual teaching hospitals for advanced surgical training. Are you ready?
Yeah, I prepared a video for that. So just give me a second.
And while people are asking, we've put the proceedings on Dropbox. So there was a Google Drive link, but that link no longer works, and I've put it on Dropbox. Apologies. Google decided to not give me any more storage on my free service. I switched to Dropbox.
Maybe you can post that on
Slack. Yeah, it's on Slack. Yeah.
I'll copy it to Discord.
Okay, cool. Are you ready, Vuthia? You're mute or?
Yeah, I share my screen. Can you see?
It's all black screen at the moment.
Black.
That I'm seeing.
Oh, it's crashed now.
It says started screen sharing for me, so maybe it has to load.
It definitely seems that you're sharing something, but
I'm really sorry it crashed. I will share again. Can you hear me?
Yeah, I can hear you.
All right.
Try that again. There you go, blue screen now.
Yeah.
Go for it, cool.
In this work, we present an advanced collaborative virtual reality environment to improve several aspects of liver surgery planning and training procedures. The proposed environment allows multiple users either co-located or remotely to collaborate within the same shared virtual environment for improving team training and
Can you?
Are you there, Vuthia? Oh, okay. What I would suggest, Vuthia, how about you send us, you're on mute. Why don't you send us a link to the video and just put that into the Slack channel if it's not gonna. Okay, you're on mute.
I'm really sorry for that. I prepared a video, but the video was crashed all the time. Yeah, hi, I'm Vuthia. I'm from University of Magdeburg, and my paper is toward virtual teaching hospital for advanced surgical training. As you already know, that collaborative VR has been utilized to support communication and team training in various fields, especially in medicine. Existing virtual training environment are focused only for specific medical skill and are conducted in a single virtual room. However, medical challenges are often in the context of the planning and operating room interventions. So in this paper, we propose an advanced surgical training environment. We also call it virtual teaching hospital that support multi-user and photorealistic avatar. It also support the training scenario that ranging from the planning procedure to laparoscopic surgery training in the virtual operating rooms. So there are three main rooms here: a lobby, a surgical planning room, and a virtual operating rooms. A lobby, it's allow the user to gather and form as a group and explore the environment and also with the interaction technique. So the user can initiate a training from the lobby. For surgical planning room, for planning a station are proposed, a virtual organ that show the patient case. So the user can select one case and explore the patient information, for example, medical history in the station number 2, and also explore the medical data set in the station number 3. We call it a DICOM board. And they can also conduct or perform the virtual resection planning with the risk map visualization at the station number 4. For virtual operating room training, the aim is to provide an interprofessional team training between the surgeon and anesthesiologist. So we also integrate the laparoscopic instrument for allowing the user to perform the laparoscopic surgery training. This prototype was evaluated with a pilot study with 6 participants. 5 were surgical residents and 1 were medical students. So valuable insights were gained and collected regarding the usefulness for surgical planning and training and system features. Yeah, thank you so much.
Great. Okay, so up next we have Deborah's group, presented by Harold Haroldson on designing extended reality guidance for physical caregiving tasks. Are you ready, Harold?
Yes.
Go for it.
All right, just confirming, are you seeing my first frame?
Yes. Yes.
Okay, so this is a pre-recorded video, and let me just play that through for you. Hi, my name is Harald Haraldsson, and I'm here to introduce our work, Designing Extended Reality Guidance for Physical Caregiving Tasks. In this short paper, we explore the opportunities and challenges of designing XR technologies to support the collaborative work between family caregivers and clinicians as they attend to the physical care needs of patients in the home setting. Our envisioned XR care system supports a local caregiver who is co-present in a shared physical space with the patient and a remote clinician. As with all remote collaboration, the communication space is virtual and participants must rely on technical mediation for communication. The local task environment is captured with depth sensors. This synchronized depth and color data is then reconstructed into a real-time 3D representation of the task environment, which includes a live 3D representation of the caregiver and the patient. The remote clinician uses a virtual reality headset to interact with this real-time 3D representation. The local caregiver is equipped with an optical see-through head-mounted display, which overlays virtual content on top of the real environment. As the local caregiver seeks guidance from the remote clinician on a specific task, the clinician is able to create 3D annotations, which are then rendered as virtual content in the caregiver's field of view. These types of annotations are one of the 4 interaction primitives we've identified as needed to support XR care applications: pointing, gestures, gaze, and annotations. These primitives are the building blocks that will be utilized in the construction of all care tasks, as can be seen in our initial XR care prototype. The prototyping takes place in a lab environment, with 2 researchers playing the roles of the local caregiver and the remote clinician, using depth sensors and head-mounted displays as mentioned before. Here you can see the local and remote settings as implemented in the prototype. The remote clinician annotates the live 3D representation of the local environment, which is then visible to the local caregiver as virtual content through the optical see-through head-mounted display. With the remote clinician represented by an avatar, all 4 interaction primitives can be seen here in action: pointing, gestures, gaze, and annotations. Compared to common remote collaboration scenarios, the tripartite nature of XR care creates challenges, but also opportunities to explore novel techniques for interaction, which we intend to further prototype and evaluate. For more information, please see our paper. Thank you.
Great, thank you, Maximilian. Okay, so up next, oh, sorry, that was Harold. Too many highlights on my screen at the moment. So up next is Paul Watson, who's going to talk to us about ragdoll recovery, manipulating virtual mannequins to aid action sequence proficiency. Are you ready, Paul?
Let me just share my screen. Can we all see what I can see?
A desktop with Slack, yes.
No then. Let's try again.
I'm reaching out to the people that are speaking on next as well. So, okay, we can see your desktop. There we go. Okay, go for it.
Oh, fantastic. A little video for you.
Okay, great. Go for it. Just turn the volume up.
The aim of this prototype is to help teach people how to perform the recovery position. Now, the recovery position is an action sequence that you apply to someone else to put them into a comfortable position whilst they wait for medical attention. And it's one of the main skill sets of first aiders, and will broadly across general public, industries, and medical professions. So we have three key aims for ragdoll recovery prototype.
Just turn it up a bit, Paul.
Turn it up.
Yeah.
Two is an environment where they can practice it on a virtual character, and three to give the learner some sort of variational practice. So let's just have a quick look at that. Listen and feel the definition and what the movement together. As you can see, you have two virtual avatars here. They're demonstrating the recovery position, and the user is able to walk around in the 3D virtual world and have a look at these movements from a variety of perspectives that suit the user and have then transpose that knowledge onto their own body.
Hey, Paul, maybe just stop the share again and try sharing again with the sound option on. I think you might have not selected that as comment in the chat.
Oh, no.
Just try that again. Or you can
share audio with the screen.
Yeah, you possibly didn't do that. And we're happy for you to restart again if that's okay.
Yeah, if not, I've got a link I can send out.
There's a little small box on the bottom left when you go to share screen, and it's not very obvious. A couple of people have given you some suggestions.
Okay, yeah, I see it. Thank you.
Don't stress, just relax. It's okay. It's just a workshop. You have plenty of time.
I didn't even know that was a checkbox, so I've learned something.
Try that now, Paul.
Hello, and welcome to this presentation on ragdoll recovery, which is an application where we're going to use virtual mannequins to help train action sequence. So the aim of this prototype is to help teach people how to perform the recovery position. Now, the recovery position is an action sequence that you apply to someone else to put them into a comfortable position whilst they await for medical attention. And it's one of the main skill sets of first aiders and used broadly across general public, industries, and medical professions. So we have three key aims for the ragdoll recovery prototype. One is to demonstrate the recovery position to someone so they can practice it. Two is to allow an environment where they can practice it on a virtual character. And three, to give the learner some sort of variational practice. So let's just have a quick look at that.
Check that the casualty is breathing by gently tilting their head back. Listen and feel for breath on your cheek and watch for movement of their chest. Only proceed to...
So as you can see, we have two virtual avatars here. They're demonstrating the recovery position, and the user is able to walk around in the 3D virtual world and have a look at these movements from a variety of perspectives that suit the user and help them to transpose that knowledge onto their own body. And when the user is ready, they can spawn a mannequin that uses ragdoll physics to approximate the movement of that body when it's interacted with. And in this way, a user can practice the recovery position on the mannequin whilst also watching the avatars demonstrate it. Additionally, we have a room where a user can practice the recovery position on the mannequin without the aid of the avatar demonstration. And in this room, we provide a couple of starting positions to add variation to this practice. So we're really interested in testing this prototype to see if it can work as a revision tool or part of the recovery position learning pathway. We also want to look at student and teacher perceptions on using virtuality for the recovery position, but more broadly, how virtuality can be used for process learning within broader educational pathways. We think that there are some interesting directions with this prototype as well, especially when we consider high fidelity interactions to try and improve the sense of mannequin movement. Also want to see, to what extent can more bespoke ragdoll systems be used for different ragdoll shape sizes and scenarios. And also we feel there's a place for using machine learning and AI approaches to evaluate the learner success, and this can be part of a feedback experience for the user. Thank you for listening. That has been a really brief tour of ragdoll recovery, an application developed between me and my colleagues at the University of Plymouth.
Great.
Hello and welcome.
Thank you, Paul. Awesome. Okay, so up next we have Amin.
Yes, Amin.
Design and evaluation of an immersive guided local regional anesthesia simulator. Are you ready? Go for it.
Do you see my screen now?
Yes, we do.
All right. So I will present our ongoing work on designing an immersive ultrasound guided anesthesia simulator. So this work is done by my students. So local regional anesthesia aims to temporarily paralyze the peripheral motor block, like limbs, and by injecting some anesthesia using a needle and guided by an ultrasound. So current training systems are based on physical simulators using probes like the one you see on the screen. The problem with these simulators is that they are expensive, not that much reusable, and that doesn't allow for objective measurements. So our objective was to design a VR simulator with training objective focus on hand-eye coordination skills. So we follow the user-centered design approach, and we designed this Spark task trainer you can see on the screen, where you see a block representing the body part the anesthesiologist will work on. And we have the tools, the probe and the needle, controlled by the haptic devices to allow force feedback. And the user is wearing a head-mounted display to see the scene. So we have conducted a first evaluation of the system, face and content validation, where we have 18 anesthesiologists, 7 experts and 11 beginners. They have tested the system and answered 2 questionnaires. Our main findings are that the system is quite promising, more particularly adapted for developing hand-eye coordination skills. But we have still some issues, mainly related to the fidelity for the force feedback, particularly when the anesthesiologist control the needle. So we are currently working on improving the system for the next iterations. All right, thank you.
I was on mute then, sorry. We're doing paper number 10, and Sarah is going to be speaking next. So are you ready, Sarah?
Yeah. Can you all see my screen?
Sure, yep, we can.
Okay, awesome. Hi, everyone. My name is Sarah from Duke University. We are presenting our work on augmented reality assisted surgical guidance system for neurosurgical application called ventriculostomy. So in neurosurgery, minimally invasive approaches are desired for maximal safety for all patients, but surgeons face difficulties due to the limited field of view, and their approaches often rely on surgeons' level of expertise and knowledge of the anatomical landmark, especially external ventricular drain, so-called EVD, is a common procedure in neurosurgery and a part of ventriculostomy where a surgeon needs to insert a catheter tube through a patient's skull and target the lateral ventricle to drain fluids and monitor the pressure. So we integrate both image registration and tool tracking in our system to provide the assistance to surgeons for this EVD procedure. So we utilize OptiTrack cameras to track the phantom model and the EVD catheter and computed the transformation of world coordinates between OptiTrack and the Microsoft HoloLens 2. And a patient-specific ventricular model was also extracted from the CT scan. And we created a mold filled with jello for the target location inside the phantom model. Here you can see foramen of Monroe is a target location that the surgeons will be targeting with the catheter, and it will be aligned with the point inside the mold. And here are some snippets of each part of AR-assisted EVD procedure with both ventricular and catheter holograms. The user first localized to compute the transformation and then inserts catheter with the tool tracking. And once the user hits the target, then there's an inner stylet inside the catheter tube that will be removed. So we reported preliminary results of some registration errors in comparing two different localization methods. And overall, the registration error was about 1 millimeter across each axis. And we found Buforia, the marker detection method, as a more reliable approach. So we plan to improve the tool tracking by optimizing the configuration of markers and then continue to build more intuitive workflow of our system for surgeons, and then ultimately prepare our system to be ready for the user studies in clinical settings. Thank you.
Great, thank you, Sarah. So up next, we have challenges and opportunities for playful technology in health prevention using VR to supplement breastfeeding education, and Kaiming Tang is going to present that.
Yep, I'm ready.
Okay,
Could you see the first frame of the video?
Yes, we have. Go for it.
Thank you.
Thank you. Cheers.
Hi, I'm Kim Meng. Today I'm going to present a workshop paper about challenges and opportunity for playful technology in health prevention, using VR to supplement breastfeeding education. Breastfeeding brings many benefits for parents and children, but the process can be very challenging. Antenatal education promises to equip parents with the understanding about the feeding process. However, the current approach taken by breastfeeding education makes little references to the lived experience. As a result, parents do not gain enough insights into the feeding process, leading to surprises when they are confronted with the reality of breastfeeding. Building on the potential of VR and conveying inaccessible experiences, we developed a VR breastfeeding simulation with parents and parents-to-be. Our simulation consists of an Oculus Rift VR headset, a lip motion hand tracking controller, and tangible representations of a baby. In the resulting simulation, user can experience the process of latching a baby and nursing in different built environments with and without the presence of other. We evaluated the simulation with 10 participants. Here we present a subset of our data. Generally, participants noted that the simulation was fun and engaging, and it triggered a flashback to memories in the early day of parenthood and prompted a reflection on the experiences that breastfeeding parents have to go through. Participants suggest that it can be used as a conversation starter with healthcare professionals and with other parents to discuss about the lived experience and the potential challenges. Our data suggested that nuances conveyed in the simulation reflect the reality of breastfeeding. However, participants noted that the vague reaction of the virtual baby hindered their user experience, because they were anticipating gameful elements that provide explicit feedback about their in-game interaction and their performance. There were also a suggestion to provide narration and context akin to what is provided in games. Reflecting on our findings, there's a number of challenges to be addressed. Our intention to convey a nuanced lived experience was challenged by the participant anticipation for a game-like experience. This raises a tension between a need to convey a realistic view of breastfeeding, which is nuanced and uncertain, and an experience that is in line with what users expect from VR. Here we argue that the introduction of game elements need to be done in a subtle way to avoid distracting the core experience and the challenges of breastfeeding that need to be embraced. Considering the widespread popularity of games, many users will bring expectations from games to the simulation they engage with. We speculate that the expectation issue can be addressed by 3 strategies. 1. Providing context to the simulation. 2. Gradually reusing game-like elements. 3. Integrating juicy elements into the simulation design. In other words, introducing exaggerated implicit visual and audio feedback.
Thank you.
Perfect timing. Okay, so up next is Joaquin again, and he's going to present to us design requirements to improve laparoscopy via XR. So when you're ready, Joaquin. Trying to do too many things at once, too many buttons.
Okay, yes. Are you seeing my screen now?
Yeah, we've got the right one this time.
Okay, good. Thank you. So I'm going to talk briefly about what we want to do in terms of improving laparoscopy. We need to improve collaboration around the operating table. And one of the problems that surgeons have to cope with is eye coordination, because they are looking at different directions from where their hands are. And we are looking at exploring using laparoscopic and mounted display to alleviate this. Oops, there was a video here. And okay, so laparoscopy is a highly fatiguing procedure, as you can see there. The problem is that what motivates this research is that people often assume unnatural poses to look at the screens instead of looking at where their hands are, and that induces fatigue. So, and also there's hand-eye coordination is something that has to be relearned when you operate in these conditions, because instead of looking at where your hands are, you're often looking at the screens positioned at awkward places. And so you have to often there are problems on communicating with other members of the team because of the positions of eyes and hands, and people do not sometimes understand where the others are pointing. And this is a well-known research phenomenon that we've published in CKI about this. And also there's no viable way to access patient data. And so we're introducing some preliminary work of LARA, laparoscopy or augmented reality adaptations, where by using a head-mounted display, you can now focus the attention of the surgeon on the theater of operations. and you can instead look at what your hands are doing. And you also can call up data from image geology that has been collected from the patient. And you can navigate those data instead of asking an assistant to call up those on the screen, go out of the area of operations. And you can even use, that's an interesting thing, you can use your feet to manipulate the cursor in a situation where your eyes and your hands are busy. You can really instrument the shoes of physicians in the operating room to assist in manipulations, and also can use auxiliary reticules and cursors that are geared and controlled by surgical instruments to help communicate references to other people in the operating room, assuming that everybody is wearing optical see-through head-mounted display. And this is part of an ongoing research that we are doing. We have not, so much of this is still simulated. We have not got to the operating room, and we are using synthetic video. And we thank you for your attention. So we feel that combining Internet of Things, perception-based interfaces, multimodal input, and AI and machine learning for improving user interface and gestural languages, we can bring new opportunities for research to the operating room. Thank you very much for your attention.
Thank you, Joachim, again. Okay, so up next is paper number 13, and Christopher Tacker is going to present that, the development of a common factories-based virtual reality therapy system for remote psychotherapy applications. Are you ready, Christopher?
Yeah, I should be ready. Let me share my screen. Share sound. Okay, I just have a video, so I'll play that.
Okay, go for it.
Hi, everyone. I'm so excited to be here today to talk to you all a little bit about my research, which is a common factors approach to the development of a VR therapy system for remote psychotherapy. Since the COVID-19 pandemic, over 2 in 5 people struggle with some form of mental illness, and only 45% of those people receive any treatment at all. This amounts to over 52 million people struggling with mental illness but receiving no treatment whatsoever. Why is that? Why are there so many people struggling with mental illness and not receiving any treatment? Well, one of the reasons, one of the biggest barriers to treatment is a feeling of a lack of accessibility. And that can be geographically, that can be psychologically, or that can be economically. And so with all of those where in-person therapy feels inaccessible to them, remote therapy is an option. However, in several remote therapy options, it can really struggle with facilitating the therapeutic alliance, which is important to healing, and the environment, which is vastly important to healing. And this is because, well, over a distance, some communication is lost, and very deep forms of communication is important when facilitating that therapeutic alliance. And the environment and remote therapy options cannot be controlled. And so in this talk, we're proposing that VR and EEG can be really powerful tools for facilitating those common factors that may be lost. And this is because VR can transport people into restorative environments where they feel safe and comfortable, and EEG, real-time EEG feedback, can help give therapists that information that is lost over distance when they're communicating. So here, I just want to show you some images of our designs and just talk you through some of our design decisions. So to start, we had a forest world and developed that in an open world space to build agency where you can explore anywhere you want to go, whether by the waterfall, by the mountains, through the trees, and really emphasizing the power of nature. Here in the log cabin environment, there's just large windows to access to nature, crackling fireplace, and comfortable furniture. And finally, in the Freud therapist's office, this was inspired by what Sigmund Freud valued, which was to display a sense of expertise, muted tones, very comfortable furniture. We developed therapist avatars to match up with the key therapist characteristics that are important for clients to trust their therapists. We started with a proof of concept study aimed at determining the functionality and usability of the system for therapists. And so I just want to display some of the really promising results that we found. Here's the client reaction system and the perceived restorativeness scale. If we found a score of 3 or above, we were very excited, and you can see we met that goal. Here we use the SEQ, which was intended to analyze the therapeutic alliance, and if it was a score of 20 or above, across all of those, we were very excited about that. And finally, the presence questionnaire just evaluating how well the VR created immersion and presence in people. We hope that through this research and further development, we can bring a system that actually reaches people where they are and helps those struggling with mental illness and feeling like they have nowhere to go to have something that can work for them. Thank you all. It was wonderful talking with you all. Hi, everyone.
Great. Thank you, Christopher. Okay, so up next is Helena, and she's going to talk to us about her paper. So she can introduce herself. Go for it. You're on mute. AR for
I should
remote.
have tested this early on.
So it's paper number 14 for those that are keeping track.
Yeah, right.
AR HMD for remote instruction in healthcare. So whilst Helena's doing that, I'll interlude. A couple of people have asked about the breakout sessions afterwards. So we'll go for a short 10-minute break once we finish the, you keep going, Helena? What? We'll go for a 10-minute break after the lightning talks and then come back with a couple of invited talks, and then we'll chat to you about the breakout sessions. And if you need to go before the breakout sessions, either to go to sleep or wake up or another workshop, feel free to do that after 11. And we'll talk a little bit more about that. Is that going, Helena, or you're stuck?
Well, I think I might be stuck because it keeps saying that I need to give Zoom some like preferences, and I'm like, you have those preferences. I don't know what you're talking about. So it's
You
not
may
letting
need
me
to change
share.
permissions on your computer.
Yeah, yeah.
How about I
Does it
switch?
seem-
Shall I switch to another one and then
Does
come
it
back to
seem
you?
like worth it? Sure.
Okay, so we'll switch to number 16, which that person, Ignacio, who's also a colleague of Helena, can't make it. And I have a video here to show you. So let me just share that video. See if that works. Oh no, let's not try it that way. Let's do it. Oh, why is that? Okay. Hopefully that's working.
Hello, I'm Ignacio Avellino, a permanent researcher at the lab IEEE, part of Sorbonne University. I will be talking today about our position paper From Déjà Vu to Déjà Vécu, Reliving Surgery in Postoperative Debriefing. I want to thank the organizers for allowing me to present, although I cannot join you live. Let me start the presentation by giving some context into the surgical domain. Here, learning is a continuous activity that is based on a model of clerkship. In clerkship training, students are required to rotate through different medical specialties and treat patients under the supervision of experts. Now, much of this learning happens in the classroom, in the hospital hallways, and in the OR. In particular, in the operative room, this involves an expert doing surgery while teaching a novice by allowing them to perform certain parts of the procedure in a progressive fashion until they're ready to become independent. This means that many times there's the need to act and learning becomes secondary. Now, one way to capitalize in those learning experiences is through postoperative debriefing. Here, there is no time pressure as in the OR, and there is time to reflect and learn. And research already shows us that this retrospective analysis technique indeed improves learning. Current techniques for debriefing rely on video, and this is mainly because video can be used for a self-confrontation. And research has shown us that this can improve surgical skill acquisition. Now, video becomes limited because one, it can only provide an outside view, and two, as more and more data is produced and recorded in the OR, we can only fit so much in video, and this more data that is recorded can be beneficial for debriefing. Now, what we propose is to move beyond video and use virtual reality for postoperative debrief, in what we call immersive postoperative debriefing. The goal is to go from having the experience of seeing, so déjà vu, to the experience of living, déjà vécu. This project is just starting, so we don't have results to share yet, but we do believe that VR for postoperative debrief can not only overcome the limitations of video, but it can also bring new opportunities, namely to support selective attention, to enable experts to live experiences, remote experts to live experiences, and to enable experiences from others' perspectives. Now, by supporting selective attention, what I mean is that as multiple data sources are presented in VR, this can be done in a natural way, such as looking at the heart rate monitor to acquire information about the heart rate, and this is done in the same way as in the OR. So we want the sources of information to be accessed in the same way as they're done naturally. Second, we want external experts to relive these experiences. VR will open the opportunity to providing external experts to be part of these experiences remotely and participate at the same level as the people who actually participated. And third, to enable re-experiences of colleague experiences, from the colleague's perspective. So immersive debriefing can provide an opportunity for surgeons to put themselves in someone else's shoes, and this can, for example, include nurses or paramedical staff, which will engender empathy and it will enlarge the comprehension of the activity. Again, we don't have results yet because we're just starting, but I do hope that our position paper inspires others to also explore this research direction. Thank you for listening, and I wish you a lovely time at the workshop. Bye.
Okay. Thank you, Ignacio. Exit out of that screen for me. That's that one done. Okay, are you ready to go, Elena? Or is it still causing you grief?
Well, let me give you one more try. And then if not, I sent you a link.
Okay.
No, it acts like I haven't given it access.
Okay, send me a link and I will download it while I have the next talk. So the next one was by So-Young Yu from UCL with Anne Blanford, Augmented Reality and Surgery, Human Factors, Challenges and Future Steps. So-Young, are you ready to go?
Yeah. How do I share this? There you go. Great.
Okay, are you ready?
Cool. Oh, hang on, I'll just go back. This. Hi everyone. My name is Sujang. I'm from the UCL. So today's talk, I'm going to talk about AR and surgery, human factors, challenges, and future steps. So mainly this talk is nothing about just work. Is more like discussion point that I'm questioning myself, and maybe possibly we can discuss further in the breakout rooms. Oops. So AR has shown much potential when applied in the surgical settings, which can help guide surgeons through complex procedure and provide heads up and hand-free information. So again, it's very intended to trigger discussion around where we are now and the direction we need to go. So for that, I highlighted 3 areas that I love to discuss further on, which is interaction mechanisms, content, and technologies. So surgeons with the operation theater often need to use both hands when performing a procedure, relying on external mobile monitors for guidance, requiring the surgeons to look away from the patient. So voice command is commonly used in the commercial HMDs, such as Microsoft HoloLens, RealWear HMT, but current application of speech input, however, have been limited to rig the command to perform navigation tasks through a system. So while this method of interaction can be require no hands to operate, its reliability of recognition can be affected by an individual accent, voice muffled by a mask, and noise environment such as operation theater. On the other hand, mid-air gesture interactions requires explicit hand and arm movement to be registered by external cameras of the device. While it can be more reliable interaction method, it may not be feasible in some surgery settings where the surgeons need both hand to complete an operation. And another thing of the content, mainly there has been a lot of work demonstrating AR's potential for real internal information about the patients, such as CT images and laparoscopic images. But generating the content is in an area needs to discuss, as this usually needs to be constructed before using the system. So 3D content can be created manually, but this is time consuming and can be inaccurate. So also a challenge with the 3D content is complexity of the model, while can increase the mental load of the surgeons. So that needs to be discussed. And two of the key challenges with the technologies are tracking and comfort. And for tracking, marker-based and markerless are two different methods which enable the computer to position digital content with the real world. Marker-based tracking using patterns or images and can provide more stability, but may not be practical, particularly in the steric environment. And in terms of comfort, while these are issues around weight of the current HMDs, which can be a problem in the long surgeries and will be, needs to be looking into the future research. Thank you, and sorry for the noise outside. They're having birthday party, so I mute myself.
Okay, thank you, So Young. Okay, so the last paper is AI HMD for remote construction and healthcare, and I will share my slides, which is actually presented by Helena. With a Zoom
Great,
thingy
I
on.
appreciate it. Yeah.
Why did you
Seriously, it's not a real meeting if there were no technology problems.
Yeah, I reckon. Now where's my thing gone? Is it? Can you see that now?
That's it. Yep. All right, you can go to the next slide. So from my perspective, there's a wealth of prior work in the field of CSTW, that's computer supported cooperative work on remote instruction on physical spaces and the benefit of the view of a shared workspace. Did it kick you out?
I just keep going, keep going.
That's okay. When you get a chance to show the first picture. This is supposed to improve situation awareness, improve conversational grounding. It's supposed to improve, of course, communication and collaboration. And tools like virtual pointing and annotation is also supposed to support the quality of work on physical tasks. So the problem with a lot of this work is all of this was done by a local worker seeing a shared digital workspace through a separate monitor, which means that they had to switch their attention between the real world and the virtual. So now, next, you've got AR as a head-mounted device, there you go, where the local worker can now see the annotations expert produce overlaid directly onto the real world, as we've seen a few other people point out. That means that you don't, have to engage your hands in order to work with other displays or look away from the workspace. You can go to the next slide. So some of the things that our group has seen is a couple issues when we've started applying this into a healthcare environment. So the first one is that there are usually multiple local workers. And we've been looking at this in primarily laparoscopic surgery, telementoring laparoscopic surgery, and EMS work. So for instance, you usually have 2 or more surgeons or medics who are part of a care team working together to achieve the desired health outcomes and consistently monitoring each other and maintaining some awareness. In laparoscopic surgery that you see here, there are 2 surgeons, typically on either side of the patient table, coordinating their maneuvers with the instruments, and the nurses and other techs are also monitoring some of the work that's going on. And the next picture is paramedics. So you have 2 or more paramedics who arrive on a scene to provide care. And the problem that arises when an individual AR-HMD system is used is that it's creating a private space. So in team-based healthcare, good situation awareness is key. Knowing what others are doing and talking about reduces errors and improves anticipation of others' actions. A seemingly simple solution might be that you should have multiple AR-HMD systems for the other local workers to wear, right? However, this in turn brings up the problem of referencing and annotating by the remote supporter consultant, for instance, and them having to deal with different perspectives and orientations and how that then influences the communication practices. So for instance, if a remote surgeon is annotating a line over the live view of the patient's abdomen, that is provided by the head-mounted camera of the surgeon standing on the left side of the table, you have to first register a line for the surgeon on the right side of the table in the right orientation. But then also when you're giving information like go to the left, go to the right, this can not always make sense if you have a medic who, like in the right picture, is at the head of the patient, and you have another medic who is aligned with the torso. Next slide. So the second challenge that we saw when we were trying to use this in the augmented reality head-mounted displays in healthcare is the fact that there are mobile local workspace views. So the view sent to the remote instructor is not actually stable. And this is also a condition of the work itself. So here with paramedicine, if a patient has multiple injuries, for instance, from a car accident, one may need to be splinting the patient's leg and then bandaging the patient's head or attending to another passenger in the car, and the camera is moving along with their body. And the next photo you'll see in surgery, oftentimes there are multiple imaging systems displaying necessary information. So in both of these situations, we have a local worker wearing a head-mounted device and moving their focus from place to place. If the local worker is looking to the right, when the remote expert is drawing and then moves their head to the left, the intended annotation will be adversely affected by that head movement. As it stands now, the Microsoft HoloLens with Dynamic 365 Remote Assist requires a snapshot of the view to be taken in order to then remotely annotate the view with annotations, for instance. So we actually came up with a new system, and this is the next slide, where we really wanted to address this like bigger problem. So
the video's not fine, but you can stick on the slide.
it's okay. If you click next, you'll have a picture. We devised something called Action Port, which is a world stabilized segment of a local worker's physical environment where a dynamic pointer can accurately reference and draw over a live mobile view. So you can see in the left here, the local worker's view, where you have your green square, which is the Action Port. And then you can see this space in the right picture, which is the remote worker's view as well. And then in order to be able to move a pointer and draw within that space, we devised Action Pad, which is a tablet or mobile phone based input mechanism that lets the remote helper manipulate the pointer to accurately and intuitively point, gesture, and to annotate in that Action Port. So this is the camera views. It's very important to point this out. I've been watching everybody's videos very closely, but those camera views that we're using are the head-mounted device camera views. They're not a separate stable camera that's being used as the collaborative digital workspace. And that little video doesn't probably play because of permission issues, but it just shows how it all works together. And anyway, I look forward to brainstorming in the breakouts. Talk more.
Cool. I think that's the end of it.
Thanks.
Cool. Stop the share. Okay. Thank you very much to all the position papers. We should give them a round of applause. Yay. And before we take a break, if everybody would like to turn their camera on, we can take a snapshot of the actual participants in our workshop, which will be really cool. Because I know some of you may duck off and not come back, but it'd be great to get a picture of you if you want to just turn your camera on for 30 seconds. Or I know that some of you, it's very early in the morning, so I apologize. I think I probably have the most luxurious time zone. And I'll give it, and I'll count to 5, 5, 4, 3, 2, 1. Yay! Okay, cool. All right. Let's take a 10-minute break. I make it 10:32, but let's say 10:32 is the time. So if we come back in 10 minutes, we'll then have a couple of exciting invited talks and then finish, get the breakout going just after 11. So thanks very much. I'll see you in 10 minutes, and well done to the position papers. Awesome work. Okay, see you in 10. Go get your coffee or your booze, whatever it is that is your delicatessen.
We work with people that have disabilities in the wide sense, physical disabilities after stroke, spinal cord injury, some cognitive disabilities after dementia, after traumatic brain injuries, and so on, and also social rehabilitation applications. So the goal also is to, the other part of the mission is to encourage research and education and advocacy, as well as improve collaboration between researchers, clinicians, industry, and policymakers with regards to virtual rehabilitation and telerehabilitation. These are our current officers. So the president, Sergi Bermudez, is currently on parental leave and couldn't join us today. I'm the vice president since 2 years now, or 3, I forget. Mindy Levin at McGill University is our ongoing president. We have Greg Burdea, who's our CEO. We have, well, you can see the name there. We have a treasurer and secretary, and we have student reps and other representatives. So we have different roles at the society, taking care of the website, awards, elections, communications, webinars, and conference. So membership is cheap. It's $50 US for 2 years. And it provides you with a lot of benefits. First of all, to be part of a networking of a network of researchers, various stakeholders, and students who are interested in virtual reality and telerehabilitation applications for rehabilitations. So we have conferences, we have workshops. After our conferences, we usually have a journal special issue to publish some of the results that took place, that were presented at the conference. We have a Facebook group, we are active on Twitter, we have a newsletter and a web page. So becoming a member also provides you with a discount to society affiliated conferences. I have a slide there. We have a couple of awards. One, we have an early career award and a distinguished service award. And we've been growing over the past few years, and we're trying to continue to grow and to evolve. Just to give you an examples of past events. So we've had our virtual conference in 2021 for reasons that are known to everyone here. So our conference is the International Conference on Virtual Rehabilitation. Anyway, before it was a different body of people doing the working in the society and the conference, but now since 2019, the conference is the official conference of ISVR. We've had 80 attendees and 3 keynote speakers. And there was, our co-chairs were Anouk Lamontagne and Jeff Wright. Another conference that's also important for the society is the International Conference on Disability, Virtual Reality, and Associated Technology. So that's held every 2 years. Also, ICVR is held every 2 years, and they switch. So 1 year is ICVR, and the other year is ICD-VR-AT. So the last one was held in Portugal in September 2021, and they were able to do it in person. Rehab Week. So we've been, we're part of Rehab Week. It's a consortium of various societies, ICOR, the International Consortium on Rehabilitation Robotics, the International Functional Electrical Stimulation Society, the International Industry Society in Advanced Rehabilitation Technologies, and the International Society for Virtual Rehabilitation. So the last one was held virtually in 2021. So we've had, this is a big conference, like joining all those, reuniting all these different societies. And together we have keynote speakers, various talks and posters. A few upcoming events. So the next one is the next edition of Rehab Week 2022. Normally it's every 2 years, but the one last year was the one that was supposed to take place in 2020, was done virtually. We're supposed to have one in person in the Netherlands, in Rotterdam, in July. So it's going to be very exciting. It's a 4-day conference. and you see all the societies. So every time, you know, we have the core societies, but they also try to invite other societies to join this event. So we'll have, I think we have now the possibility to register. The early bird registration. It's too late to send abstracts or workshops, but it's not too late to register with the early bird discount. Okay. We'll have the 14th ICD VR AT, which will be in also in September. It will be in September 2022 in person, and there's still time there to submit abstracts if you're interested in attending. Some of our resources. So we have a newsletter. We publish maybe 4 per year, where we have different news about the society, upcoming events, short interviews of researchers or clinicians or technologies. We have a journal club that was inaugurated in 2020 that's held virtually about once every 2 months. And it's really, the purpose is to have a friendly discussion on a paper or a series of paper on topics related to virtual rehabilitation. So that's free and it's open to all. So if you're interested in presenting, you can contact Sandeep. His email is there. And if you're interested in attending or keeping up to date, actually the best way is to join our mailing list. You can find the information on our website. We've had webinars as well. Again, those are free, and both the journal clubs and the webinars were integrated during the pandemic, but we'll continue because these are held virtually. So the webinars are 1 hour long conferences, and you can see we've had a few since last year, and we'll continue having those over the next months and the foreseeable future. So you can find all the information on our website, isvr.org. You can have access to, for members, we have a members area where you can have access to our past webinars and journal clubs, the recordings, as well as some recordings of our conference keynotes. You can find the conference proceedings on the conference website, virtualrehab.org, and ICD for the ICD VR AT, it's also found on our website. I talked earlier about affiliated organizations, so our members get a discount to all these to conferences and events organized by these other societies. So that's another advantage of joining ISVR. Okay, and that's it. So I went quickly, as Craig asked me to do. So if you have any questions, please feel free to ask them. Yep. I'll be happy to answer.
We've got time for a couple of questions if anyone has any. Say 2 minutes of questions. I guess maybe a question.
The membership is $50 US, and for students, I think it's 25. So it's very, very inexpensive.
I guess maybe one question while people are thinking of, if they have any, is how many computer science like people are involved in this society? Where the majority of people in this conference come from a computer.
That's a good question. Background. We have we don't keep tabs of specialties, but we do have a mix of engineers and people who are more doing clinical research and engineers. So we're very multidisciplinary.
Cool. Maybe if you'd like
we do have people who develop technology and people who are users of technology for various clinical interventions. So we really cater to both types of specialties.
Cool. Maybe as a summary, you could just share your slides on Slack, on the Slack group, so people could see them if that way, rather than me.
Sure. Okay, we'll do.
If you join the Slack, then people can join that. Cool. I mean, I could ask you questions all day, but it's mainly for the other people in the room.
Okay.
Are there other people that have any questions at all for Philippe?
That's fine. I think I was very clear.
Okay. Well, let's thank Philippe for introducing us to this International Society for Virtual Rehabilitation. So thank you very much, Philippe.
Yeah, feel free to contact me or contact the society if you have any questions.
Cool. Much appreciated. Thank you. Okay, so that leads us to our final invited talk, which will be James Hayes. And James is going to talk to us about how can VR technology enhance education and improve student outcomes. And James just let me know that he actually caught a plane from New Zealand to San Francisco last night. So I wasn't aware of that. So he's currently sitting in a hotel somewhere in San Francisco.
Sorry about that, Craig. I wasn't sure where I was going to be for this talk. Yeah. And I was desperately hoping I wasn't going to be getting up at 3 o'clock in the morning for it, but I was committed to it regardless of the time. I wasn't going to send you a video because having made this commitment in purpose. And
so,
also,
one quick thing. So just for letting people know on this community that James is not a computer science person. James has come from a academic perspective, teaching in a something known as a polytechnic. I don't know how well that word is used. So it's sort of like an applied sciences university, teaching imaging and radiography. And, you know, like a lot of people get sick of academia. So he said, I can do better. So he's gone off and done a startup and shown you the world how you could do something like this. And that's the bit that we're going to hear about, the virtual medical coaching. So VR technology to help support a range of needs in the medical space. I'll hand it over to James now. Go.
Thanks, Craig. So like I was just saying, it might be a slight apology. I'm not sure if you can hear the music in the background. I sent Craig an email about 20 minutes ago to say if there was any way we could swap the last order. They're setting up for a festival outside me. They're calling it a block party, if anyone knows what that is over here. It looks fun, but I was really hoping you can't hear it. So look, without further ado, I'm going to share my slides. So can you see that?
Yep, perfect. Go for it. Yep.
Great. Okay. So I don't usually try and hog these academic or research conferences by coming in with a sort of a promotional one. So I'm really determined not to do that. And because of that, I'm quite conscious that what I like to do is kind of an applied approach to what we've been hearing about. And the reason I'm over in the States, and one of the listeners today, and another presenter, Christopher, I met him in Nashville last week. We were talking at the virtual reality in healthcare conference, and you know, there's some absolutely phenomenal research out there. And this isn't what I don't come along to these, like I said, the sort of a nefarious reason. I just love to hear what's going on out there. My background, as Craig briefly mentioned, I worked clinically for 10 years. You'll be able to work out how old I am very quickly as I keep on talking about what I've done for 10 years. And then I went into medical imaging education. Towards the end of that, I realized what we were doing could be done better. That was about 6 years ago when, now, if you're a true virtual reality researcher, virtual reality started 30 or 40 years ago. But for most of the world, virtual reality started 6 years ago when Oculus and HTC brought out their respective headsets. Because suddenly the price was low enough that people could enter, and also their computer graphics cards meant that, you know, were cheap enough that people could buy them, albeit not available anymore. So that's how I kind of got into it. And our first topic was like Craig mentioned, in medical imaging. And then we've sort of branched out into that. And because there's a lot of people looking at hospitals in this group that I've heard this morning, and I was reading through some of the Google Drive presentations, and just because of your backgrounds working in hospitals, I thought I would talk about something that we're doing at the moment, which is a radiation safety thing. Essentially, the process is the same with what we do, but the radiation safety is quite an interesting thing, because I call it the passive smoking of the 1990s or the asbestos of the 1970s. It's something we haven't really looked at properly yet. And one of the things that virtual reality and a lot of other technologies can do to help us teach about radiation safety is it just completely changes the paradigm. So my background again was I taught medical radiation physics. Okay, so I know this stuff, or I thought I did, before I was lucky enough to be asked to be a supervisor of a student who was doing his radiation physics masters. And this was an area we sort of looked at together, and I was blown away by how little I knew. You can sort of book learn the first 85%, but actually the last 20%, those don't add up. It's very, very difficult to learn unless you've got a new way of doing things. So if we look at a lot of conventional training that we're doing isn't working. I mean, actually what I'm doing today is completely wrong because I'm speaking to a mixed audience. And this is what we have to do most of the time. There are people in this audience who know a lot more than I do about virtual reality and data science and big data analytics and small data analytics. But what we should be able to do is have, that's kind of how the existing training works. And with radiation safety, what we're not doing well is creating a course for each individual learner, just because it's far too expensive. So what happens is everyone gets bundled into a hall on a Saturday morning once a year. They get shown a machine a little bit like that one on your left, and they get a certificate of attendance at the end. Now, a certificate of attendance just means you didn't leave. The following year, they'll do the same thing. They might be no better off. But like I said, this is a dangerous topic. Both from a hospital point of view, they've got a responsibility to keep their staff safe. And from a personal point of view, you want to be kept safe if you're working in a hospital. And the only way to learn that, I believe, is in virtual reality, because we can suddenly, what you're seeing there in the second ball is the radiation, but it's in color. So very quickly, with no radiation training in your background, you can work out that red is probably bad, then orange is slightly better, and the green areas you could be safe in, but not as safe as where there's no radiation. So, you know, already by showing you this, you're going to be about 50% better educated than, not this, sorry, not by showing you this one ball, by just allowing you to go into the virtual reality, you would be 50% better educated than most people. But if we then wrap around the other stuff, and this is what I like talking about, if we wrap around the pre-assessment, so that if we look at our collection of people in the hospitals, and this I find fascinating. So you have radiologists, anesthetists, nurses, radiographers, anesthetic technicians, and cardiac sonographers. They tend to be the most common people in a theater. Of those, the radiologist and the radiographer is the best trained in radiation physics. And that's really it. Now, interestingly, the nurses, the perioperative nurses, are the worst trained. The worst trained in radiation science. So interestingly as well, they're usually in the worst position for this because they're right up by the patient, they're right by the table. The anesthetist can be at the back of the room or at the very top of the room and out of danger way. So we've got to develop a course for each of them. But because this is expensive and because the hospital doesn't usually want to let their staff learn in a physical environment, it doesn't happen. So once a year, they go through this process where they all go into a basketball court on a Saturday morning. Someone brings in a machine, they point at one end and they say, well, that's where the radiation comes from. So obviously stay away from that. The other end, not so dangerous, but depends which position it's in. And that's what you can learn in the next step, the virtual reality. And I'll go into these in a little bit more detail in a minute. But then there's a self-assessment, and that is what the data analytics is feeding. So everything you do in the first two balls feeds the third ball. So your course is developed for you. Now, the difference between a certificate of attendance and a certificate of competence or completion even is that we will only give that to people when they have shown that they're safe. So the pre-assessment, it quantifies the unknown risk and it's fast and effective. And the reason we say that is you don't have to be there on a basketball court on a Saturday morning learning this. Surgeons, nurses, anesthetists, they all turn up to theaters, and it's sometimes delayed by half an hour or 20 minutes. They can do little bits and pieces there and then. This then waits for them until they're ready to log in again. It should be engaging because it's recognizing their own strengths and weaknesses, and it looks like it is developing a course which is specific to them. This is where I'm hoping to play a short video. Please jump in and tell me if it's terrible quality. Will you do that, Craig? So the user is just in looking around the environment now. You can see all the staff there. One of the nurses at the front, he's going to be in, as soon as we flick on the radiation. So the user can do everything. They can set up the room how they want. And they've got the TVs on the wall there to see what dose they're getting. These doses were validated in a real world environment as well as in a simulated environment. And things like the perioperative nurse being on one side of the surgical trolley compared to the other, we actually found could reduce their dose by up to 70%. So when that sort of stuff is just amazing to get in a 5-minute training session or a 10-minute training session, because we're talking about quite serious effects with so the user here is able to do anything they want. Now, interestingly, not everyone will do that in the theater. Okay, so if you're usually a perioperative nurse or an anesthetic technician or an anesthetist, you'll never get access to this side of the machine. But what you will do is you'll have a load of presets to go through, because you will recognize the machines are in those positions on a regular basis. So we can get the machinery to go into those positions and see what doses people get. But because this is just the only video I had, I can skip through that. You can see the doses are all on the walls there. Craig has asked me to keep this short, so I'm going to go into it. Things like putting the lead safety glasses on, that's really important. And the reason I say that is because obviously the radiation is invisible normally. Look, I'm going to finish that. The radiation is invisible, so people get really relaxed about it. And they say, I'm only going to be in here for 5 minutes, but if you can show someone that the radiation safety glasses reduce their eye dose by between 95 and 97%, they'll wear them next time. Like I said, the personalized self-assessment, the adaptive learning, we really believe in that. From an application of these technologies, we've turned a lot of colleges and universities around to presenting the same information in the same order, but giving people different experiences, giving people the same experience by giving them different bits of information, because everybody comes into us with a different background. So we need to do that personalized self-assessment first, finding out what they do know and what they don't know. The whole thing's data driven. So this is building itself as it goes along. But what we need to do is when we're getting into the data, we need to be able to find out what the student or the practitioner knows and let the software do it. But what I like to say about the data is, and I'm going to use this ring as an example. I don't know if anyone knows this Aura ring. It was given to me for my birthday, which was about 3 weeks ago. It didn't get to me until I was just about to leave New Zealand. So I got it about 3 hours before I got on a flight to Los Angeles, and I charged it up. And then I got on an overnight flight to Los Angeles. Now, one of the things this does, and the reason I was given it is because I'm a terrible insomniac. And so my first night of sleep, according to the Aura ring, I had 4 hours and 22 minutes. Not great. The next night, I flew from LA to Houston, which gave me 2 hours sleep and a little bit. And then I flew from Houston to Nashville, and I had a few more minutes of sleep there and then. So according to the ring, my sleep pattern is terrible. It's usually not much better than that, but we'll just go on those little bits of data at the moment. So that's the data it's dealing with at the moment. It is accurate, but it means nothing. Now, when I look at it, I can sort the data, so I can kind of go, oh, well, look, I was flying and I went through to LA and stuff like that. That's usually where we stop. That's kind of going like, oh, that's data analytics. But actually what you need is this. You're saying, well, no, we want to get, and I remember hearing this once about the Lego house and the piles of Lego. So it's not an original thing of mine, unfortunately. but really this is what you're up to. You need to get to the stage where you're told a story. And for us, telling someone the story is sadly not a Lego house. My daughter would love that. She's 5 and I will be bringing her Lego home or something. But we need to give, and this is made up data, but we need to give the people and their employers accurate analytics for what they're doing, whether they have radiation safety risks when they're going, you know, before they go back to the hospital, because we can get rid of them by doing more training. Even their training habits, everything you want. Once you've got that information, you can then build that Lego house. So look, I'll skip through the rest of that because it's a little bit commercially at the end, and I don't like doing that. I'm very easy to get hold of if anyone wants to have a chat with me. I think there's some definite conversations I'd love to have after this. How was that, Craig? Was that 20 minutes?
Yeah, more or less. That's
okay, great.
Okay, well, let's all thank James, and we can have a couple of questions.
Sure. Could you hear the music, interestingly?
Not really.
Oh, brilliant. Okay, because it's really loud in here.
All right. So maybe I could start with a couple of questions. If there's no one, where's my chat window gone? It's gone walkabouts. Oops, if there's any questions there. So I guess one of the questions is, you've got a VR solution for imaging. You've got a solution for birthing. What other solutions do you have that people might be interested in?
So we were just about to release that one that I talked about, and that's one of the reasons I talked about it was because we think it's probably the most important. Like you said, Craig, we've got this. I mean, I do run a startup. If I turned off the blur in the background here, you would see that I'm certainly not a CEO in the quality of the hotels that I stay in. But the what we actually like to do, and without trying to sound like a martyr, we're trying to actually do some good. There's some amazing businesses out there, but like taking the imaging, taking the midwifery that you know about, taking the radiation safety training, and actually just saying to people, we're going to make your training more efficient, more effective. So we're treating learning as a results-orientated tool. So it should make it cheaper for students to learn. It should make it easier for students to learn. And that's really what we want to do. So we also have MRI, CT, and mammography in the pipeline. Now, you're a software developer from a while back, so you know what in the pipeline means. I couldn't possibly give you dates, but I know I've seen things working in the studio. People are getting excited. We have cake, and then they go back into development for a number of months. But yeah, we really want to focus on medical imaging, and then we've got the childbirthing and nursing stream as well. So yeah, it's an exciting stuff, and we're still waiting for you to come down.
Yeah, well, that was supposed to be this week. And in terms of, we'll come to Liv in a second. We'll go to you first.
When it was an online conference.
Liv, why don't you ask your question, because I don't want to hold the time.
Yeah, sure. This is regarding the radiation safety that you were talking about. I'm curious, is it possible to get any of that data in real time as people are adjusting, for example, a C-arm or something like that in the OR or in the interventional suite, to see where the radiation might affect them as they make adjustments and then move around accordingly?
Yeah, totally. Hi, Love. Great question. I've actually been asked that a number of times. So what we essentially do is training material. We have about 6 theater suites that are all slightly different. So that the idea is you could go into any one of these 6 training suites that we have and learn the principles of radiation safety. For example, what happens with front scatter, back scatter, side scatter, what the radiation is doing according to the air karma. I mean, most people understand that you've come from a radiology background too, haven't you?
It's laparoscopic surgery type.
So so you understand the time distance shielding principles, but that's usually where in theater anyway, we sort of, we draw a blank. So what you'd need is an augmented reality solution. Now, there is a group out there that does this. It might be Philips, but I'm not sure. So, but if you look for it, so it's an augmented reality. So then you would look at the real machine and you'd see the radiation spilling out of it. I don't know how it works because I can't I can't picture how you could develop that amount of you'd need to have your HoloLens or whatever it is connected to the image intensifier and all the parameters that they're using, which is an insane level of computation to be developed on the fly. I mean, we usually do these processing runs in winter just to heat the office. And they run for 3 months, so it's quite an effective way of heating our buildings.
Okay. Yeah. So there seems to be a lot of data that needs to be kind of computed.
Yeah, it's it was a huge amount. I didn't anticipate it being so much. And then what you're looking for is augmented reality. So at the moment with ours, in virtual reality, you could put the people, the machinery, the patient, anything you want in any position, and you'll get a real data output of what's happening to every person. And then you can change that all around as often as you want, but it's not an augmented reality. It would be good. So, and then you could sort of nearly even pair the two. So you could have a virtual reality training scheme, and then you say, okay, now I want you to have an augmented reality work environment where you might have, and this is sort of taking it to the next level, instead of your theater glasses that a lot of perioperative nurses and surgeons wear, you could wear some sort of pretty cool augmented reality glasses. I don't know if hospitals would then start to fund that. Who knows?
Thank you.
No, thank you.
Anybody else? Helena, go for it.
Hi, Helena.
Thanks. I never can find the little hand. So I really like the learning model that you're capitalizing on here. It's this active learning model, like basically mess around and figure it out, and building up your own internal understanding of the environment and how it works. And I'm wondering, from your perspective of like being in the real world, talking to real people, and how they would want to invest in a system like this, do you feel that you have to justify why this is really a better model than just like passing off a bunch of PowerPoint slides or a really big book? And, are they asking for like learning center data to prove that? Or do you feel like people really understand the benefits of what seems to be a really large system, but really I can see like the benefits that it would have for learning?
Yeah, that is such a good question, and there's so many parts to the answer. So if I could tell you just very, very briefly how I kind of came up with this of learning. I wish I had, but I had a student and in the room, and she had a master's in medical physics. Okay. No, sorry, radiation physics. I was teaching medical physics. Very, very similar, but not quite the same. Therefore, she needed to be in all of the classes to get through and to sit the exams. And I sort of said to her one day, I was like, you have no problems with this whatsoever. Why are you here? And she's like, I have to be part of the course requirement. We must attend or something like that. Anyway, she breezed through as expected. But I thought, wouldn't it be great if we could let someone like her and multiple others skip through large chunks of the course by proving competence really, really quickly. And then you could say, okay, now you've got time to spend extra in whatever other courses we have, or actually just finish the degree earlier. And this is another conversation I would love to have. That's at sort of government level, unfortunately. Now, to answer the actual question, do people support this? Some people, yes. Some people are horrified by it. And the reason for that, and I know you're nodding because you probably guessed this, but so some people look at it and they just say, oh my goodness, this is everything we need. We want to have the best environment for our students. This is the only way we can do it, because currently we're sticking, the same amount of information in front of every student, and we're hoping for the same thing. Now, most people at the very beginning of their degree are bored in some classes and struggling to keep up with it in others. And you're like, well, we could sort that all out with adaptive learning for a start. But now the people who hate it usually say to us, and I've had this said to me in these words, this is more or less verbatim, we need our students to get here, okay? And I say, we can get your students here with less work by them. And they say, we need our students to get here. And I'm like, oh my God, you know, I can't believe I'm even having this conversation. And I say, well, you know, but they're struggling, they're finding it difficult to do this learning because the resources aren't provided for them. And they kind of go, they've got libraries. And I'm like, yeah, now I would probably give up on a conversation like that. 6 years ago, when we were young and needed the money, and I say that like we don't now, but we're just not young. You know, I would try and educate and stuff. I sort of still do. I kind of try and talk about the ease of learning that you can do, rather than showing people PowerPoint slides. And I had a similar conversation with someone in Florida just yesterday, and they were kind of like, well, you know, when we were doing distance learning, we were able to draw things on whiteboards and let the students see it. And I was like, now imagine the students could do it. And this wasn't in virtual reality, this was just in a desktop environment. I said, you know, that would take your learning from 25 minutes to maybe 3.
It's just amazing how many ways you end up hearing, but that's not how we've done it. As if like, that's the justification. Not
people
to
say, oh,
things.
we don't do it like that. And we haven't done it like that for 100 years. Why should we change? And you want to say, I think you answered your own question.
Oh, gosh.
You know, where they say,
right.
we use a lot of technology, you know, and you go, yeah, you went from a wax board to a blackboard, and now it's a whiteboard. That's not a change of technology. You just, sorry.
Yeah.
This is my pet topic.
I get you. I hear it. Thank you.
No, you're more than welcome. Thank you for asking this.
Thank you, Helene. I think we should end James's invited talk there. So let's give James a round of applause. Thank you very much, James.
Thank you very much, guys.
Cool. Okay, so that leads us to the final phase of the workshop before I wrap up. So what we're suggesting now is it's 11:20 in New Zealand time, so 20 past wherever you are. What we're suggesting is for the next 40 to 45 minutes, if you join a breakout room, if you want to, or you're welcome to leave. We hope you can stay. There's still about half of you that from the very first moment this morning or evening. So we've got 5 breakout rooms. Let me share my screen because I was going to do that. I'll just do it this way. Okay, so where's my keynote? So we have 5 breakout discussion rooms. XR for medical training and education and tools. So basically training and education, and then breakout room number 2, XR for remote collaboration assistance. So focusing on the remote local aspect. Number 3, about software design and surveying for creating XR applications, or more around the software side of things. That was number 3. Number 4 is tools for enhancing treatment or supporting surgery. So more of the rehab or medical space. So that's I think quite a popular one based on the talks that we've seen. And then 5, any important research topics in XR for health. So if people want to do more talking about research studies or potential grant funding or something like that, can pop in that room. You're welcome to bounce between the rooms. And what I'd suggest is we have a lead for each of the groups. And as part of that lead, if we can have just a quick list of who you are that are in that room, come up with the 5 key challenges in these areas. Maybe it's 3 for 45 minutes, and come up with any future areas. And at the end, at 12 o'clock, we'll come back and have like a 2 to 3 minute summary from each of the rooms. And then the organisers will have the final comments of where to next. And we're welcome to hear from anyone else. How does that sound from people's perspective? Am I hearing some nods? I've just lost all the participants. Where's the participants? Does that sound okay for people? So I'll open up all the breakout rooms, and you can now just go into the rooms yourself. There's about 20 people left. So you should be able to just click on breakout rooms, I think, from the Zoom thing, and then you can just select any one of those join. when you want to switch rooms, go leave room rather than leave meeting. So if you leave room and then it bounces you back to this main room, and then you can switch back into the other room. So I'm suggesting James goes to training and simulation, and Philippe, if you're there, if you can join the surgery rehab space and potentially lead that one, and maybe Simon could join that, and I'd suggest Helena goes into the remote, or no, Deborah, if anyone from Deborah's team could go into the remote collaboration. That group was focusing on that. So we at least have 3 people there. Joachim, you can go to any of them. You've got lots of papers, and Helena, whatever works for you best. And I'll hang out in this main room and bounce between them just as a conduit. I'll put the questions inside Slack as well for those that are there. So we've got a couple of people in some of the rooms. I think some rooms are going to be a bit more popular than others. And to have a general chat. So if there's anything you guys got it sorted? I mean, Sanobar, Miriam, Simon, Regis. Cool. So you got the rest of you, have you figured out how to join the breakout room? Or I can assign you if you want me to. Sanobar, do you want me to put you in a room?
Yes, I'm trying to look how I can join the breakout room.
Just tell me which one you want to go to, and I can assign you.
That was the 4th.
Surgery and rehab? Okay, I'll put you in that one. There you go, and you'll bounce across.
Brilliant, thanks.
Simon, do you want to go or do you want to chat? Carly? Carly, do you want to join one of the rooms, or Simon? Are you guys, can you, either of you hear me? Well, software apps could hang here. Simon, you're moving to surgery rehab. Cool. James, are you okay there, James? Are you there, Carly? Do you want me to put you into a room? Jiazu Lee?
Okay. For example, apply VR for senior surgeon. That senior surgeon, they might not want to use these technologies just to do the way that they done before with their experience, just used only the 2D slides and conduct the planning instead of using VR. That the challenge.
Cool. Just a quick note. So if you guys follow what the instructions are, and then you can just post your comments into there's a separate Slack channel for that. I forgot to mention that. Sorry. There's too many things. There's a Slack channel for that room. So if you can.
Okay.
So you can just put your discussion there if you like.
Is it the research community? Oh no, sorry.
The Slack group, and then there's a channel 1, 2, 3, 4, 5. And if you just put your notes there, then people can see what you've discussed.
Yep.
Cool.
So we are in room 1.
Yes, the room called training education. So if you just switch there. Sweet. All right, I'm just going to bounce through the rooms. If you've got any questions, just let me know on the Slack or something. We'll do something, I don't know, send me an email. I'll try and pass. Thanks all for your talks today as well. Much appreciated. Okay, I'll see you in a minute.
Thanks for hosting.
Yeah, no worries. We'll come back about 12ish. So we'll see how people feel at 12. I know that's late for some of you are in Europe, so that's quite late. Some of you, I don't know, it's maybe.
We're all in Europe.
Oh, okay. few Europeans who have gone to bed, and a couple with kids as well. So yeah, I can't help the scheduling. It's the best effort. Anyhow, I'll see you soon.
I do hate GatherTown. So Verbella, well, it did go well for the posters and demos last year, and I'm looking forward to see what you do again. I'm trying to organize something called speed dating in Verbella. We did it last year for a crowd of 50, and it did not go too bad. So you can do a couple of things. You can run around. It's better than Second Life, if that says something.
Yeah, because I was not, I don't know, for the whole presentation part, I didn't really care for Virbela, because sitting in a virtual room and just having a smaller screen of seeing something that I would want to see full screen is kind of
right.
Yeah. I mean, I agree. It's probably great for doing events.
I ended up watching all the technical sessions in Twitch, Zoom, YouTube, and it was fun that you could have two different technical sessions going at the same time, and you could mix and match the papers you wanted to sit through. So we were looking more for Verbella for the social events part, where you can actually meet people by accident. It did happen. The posters thing went right. I think we could have done better in terms of social events. We had a couple of things that, so this time we are amplifying the type of events we are doing. There's a two treasure hunt type of things. And yeah, the reward was top of the line NVIDIA graphics card last year, and people were kind of envious of whoever got that one.
Yeah, I mean, they're expensive right now. It's a good price.
Yeah, we're playing with flash crowds, football games, racing.
Can I interlude for a second, JJ?
What, Craig?
If you want to talk about the topic, you're most welcome to. If you want to talk about
talking about remote collaboration.
Okay. Could you put the notes into the Slack channel on your summaries, just for the so we can share it with the others?
You have to add yourself to the Slack channel first. Let me know if you need me to add you.
I could add everybody.
Slack.
I was just like, I don't see it, and then I remembered it's probably hiding.
I'm not much of a Slacker, you know.
Yeah, neither am I. I don't really have it.
It's just so that we could share the notes with them. Otherwise, because the breakout room chats will die when you close the breakout rooms.
Okay.
I mean, you can talk about it, but just
that's how you keep it like where all the cool kids are. Like, you want to go to that breakout room because then you're part of the conversation.
Greg, if you are recording.
But it doesn't record the breakouts, does it?
I don't.
Oh no, never tried.
It says
I don't think it does.
recordings in the top left, and when you joined, it said recording starting or something.
When I joined?
Yeah,
Yes.
but I think once you go to,
It's probably because
I'm not sure.
it's probably following me around the rooms.
That's what it's probably doing.
So don't, don't say anything bad while I'm here. Anyhow, just put the notes there will be fantastic, and I'll bounce to the other rooms. We've only got 3 topic areas that selected, and we're down to about 20 odd people, so it's to be expected, right? So,
cool.
Yeah, I'll let you keep going. I'll bounce around. Thank you.
Okay.
So, well, maybe one challenge that I see, and that's which is true for all health-related technology, is making sure that that these technologies are accepted by those who are supposed to use them in the end. So that the healthcare field is a very the people are usually very busy. They have their own culture, if I may say so, and they have their own ways to do things. So introducing any new type of intervention or any new type of technology or training tool requires that that there's acceptance by the clinicians if it's aimed at them, and that I think will remain a challenge. So
Quick comment. Well,
that would be my first thought.
I've set up a Slack group, so if you could post any comments you have about the summary of this discussion by the end of it, just so that we can share the notes with others. Doesn't have to be world-class notes, just has to be something. Cool.
Okay.
Is the Slack group still open? I tried to join earlier. It said it's not open anymore to join.
Oh, really?
At least the link.
I'll add you now. How does that sound? I thought I left it available, so I'm not sure.
Thank you.
It says never expires. See that one can you see that in the chat window now, Simon? Is that Simon? I think it was Simon asking the question.
Yes, that's me. Yeah, seems to work now. Thank you.
Okay, cool. And I can appreciate that it's quite late for some people. Some people have had to drop off with kids and bedtimes and that kind of thing, and quite early in the morning for Asia.
Yeah, so I mean, just talking about challenges, I think there is the very mundane challenge of technology, especially for, I think, the work that Sarah has presented, and deals with the precise registration of an anatomic model on the actual view of the actual model. So I think that's in terms of the conceptual model, that I think is quite feasible, but the technical limitations in terms of latency and jitter and all of those important issues that we wish weren't there, but they still are, I think, can be a bottleneck in the actual implementation of some of these techniques.
Right. Especially for AR application, that the standards standards for the accuracy in medical fields is like they call it sub-millimeter. So they want the for AR application to overlay a hologram onto the accurate positions. The surgeons desire about 1 millimeter of the alignment errors, and I've seen lots of papers and other researchers been doing with just the marker-based visual marker with the Argo type of markers. But then the reason why we use OptiTrack cameras for our project was because of that accuracy. We wanted to get down to that sub-millimeter level. So
Yeah.
Why do we need a sub-millimeter? Why do they require that level of precision?
Well, to overlay the hologram of the patient-specific model on top of the actual patient's head. Yeah, because it needs to be aligned. Yeah. If that error accumulates, then obviously what surgeon will be seeing in AR will be, more obstructing, or it could lead into failure of the surgical task. So
Yeah, no, and just to complement that, I think so. The use case I think that you were working in is the the EVC or the external ventricular placement, right? Of
EVD. Yeah.
Oh, EVD. Yeah. Sorry, the external ventricular drain placement of a catheter, which needs to go into the ventricle of the patient, and I guess, and I'm saying that because I sorry to step on your work, Sarah, but as I mentioned before, I had some influence in the initial concept, but yeah, so typically the surgery is planned ahead of time with landmarks that are set by looking at the image, and then places like where you're going to make the decision, but it's also very higher rate with just typically residents performing this in the US, at least, performing this procedure, and you poke the brain like 3 or 4 times before you actually get to the source of the pressure. So the goal here is to reduce that error, I think, and chance of error and tissue damage. Increase the success in a very low bar, I think, surgery, because it is so imprecise to begin with.
Yeah, and like you mentioned, other reliability of, latency of holograms, or some jitter, sudden jump of holograms. I mean, those are all those factors of the reliability for one of the challenge. Yeah.
Did you talk about the differences between different types of surgeries and what you'd need within AR, VR? I know some of you are focusing on the rehab side of things, but if you're developing a VR solution, can you easily translate that from one medical type of operation to another? The reason why I ask is because we're working on that. Or what is that a challenge? Like, I mean, rather than trying to develop a bespoke application for everything, is there a core thing that you could do that could relatively easily switch across to these other systems? And the comment being is that the medical research or medical devices and people I speak to on a regular basis, they all have hey, we have this solution for our niche medical area, and within AR, VR, can we easily change that? So for example, we've been building systems for electrophysiologists, and building stuff for radiation therapists, and we basically use the same code base, and we can relatively switch the applications from a main source. So I don't know if any of you are in that area or working on maybe one or two. For example, rehab, we've also been doing stuff around pain management, so we're supporting people that have chronic pain and have different applications that they can switch to. So don't know, it's more of a software question because I come from a focus.
Yeah.
Well, I think that the concept of overlaying markers, like kind of X-ray vision type thing, onto different regions of the body is quite generic. There are some issues, I think, with different types of organs, especially organs that are deformable and also more dynamic than the brain. For example, the heart that's beating and all that. So I think that's one challenge. But I like for bone operations, stuff like that, I don't think that would be a challenge. And then the second challenge, I think, is more data and image oriented, which is, I think, for each application, you would need to develop algorithms that could quickly reconstruct the organ from from an image or a set of images from a DCOM set to be able to overlay. So I think those are the main challenge, or some of the main challenges for general application of this idea of augmented reality guided surgery.
Okay, yeah.
I'm sorry, I have to leave. I was not. Also, just want to thank you for inviting me again, and yeah. So good day to you all.
All right. Au revoir. À bientôt.
I have to leave in a couple of minutes too. I'm going to check out another breakout room really quick before I have to head out. But it's nice to meet you all.
Yeah, thank you very much for your time. Cool. So we'll go for another 10 more minutes in the breakout, or till 12 o'clock. So then if we come back, and we can just wrap up from some of the rooms. So Regis, you're based, whereabouts are you? You in?
I'm in North Carolina, in the US. Yeah.
And whereabouts are you, Sam? Sarah, sorry.
Same here. But I'm at the Durham, North Carolina, at Duke University.
Triangle Cities. And Sanova, whereabouts are you?
Yes, it's UK, United Kingdom. So
Yeah,
yes,
University. Okay, yeah.
we're approaching like 11 o'clock at night, so I might dash off.
That's okay, no problem. Like, it's just coming up to lunchtime here for me, but it's a Sunday, so I get it. It's not the most convenient time. And Simon's in Christchurch, so he's the actual only local person. It's in the real space. You're probably actually sitting in the room we're supposed to be in, Simon. I don't know. So maybe if you could at least add your comments and into the Slack channel for your notes.
Sure. Right. Thank you so much for having us, and thank you so much for letting me speak and giving me the opportunity to present my work. It was lovely meeting you all, and it was nice hearing about what people have done in terms of VR and in medical context. So yes, you enjoy the rest of your day, evening, or afternoon. Thank you so much. Bye for now.
Have a good sleep. Bye.
Bye.
Cool. So which areas are you working on again? Regis, you didn't have a talk though, did you? Or did you? I don't think you did, right? Did you have a
You asked me?
Yeah.
Oh no, I didn't, but I was really happy to see Sarah presenting work that is that is an extension to work that I started at Duke 5 or 6 years ago. So that's why I was talking a little about that.
And Sarah, you're a PhD student or something, is that right?
Mm-hmm. Yeah, I'm in my second year of my PhD student. So I started this project last year. And yeah, I've heard about, people in the past who started this project, but now it's getting some, momentum to make some good progress. So yeah.
Oh,
Cool. And Simon, what are you currently working on? I know you got a range of things, but maybe in the context of this.
Yes. As you know, yeah. No, I have 2 PhD students currently working on. One is working on multiple sclerosis, virtual reality for multiple sclerosis rehab, or essentially training, and another PhD student is working on at the moment improving the therapist communication with the client in virtual reality acquired brain injury rehabilitation on site. We'll have soon a third PhD student who is going to work on multisensory virtual reality for acquired brain injury rehabilitation as well. So that's 3 areas where I'm co-supervising students right now.
Where are those 2 students? Are they sleeping? Because mine's, I think, gone back to sleep. They were here.
Yes. At least one of them was here earlier.
Yeah, that's good. Yeah, so the aim is to get PhD students talking. We had 5 students in our research group at the doctoral symposium yesterday out of 20. So I think they were pretty tired after that. And 3 of them are medical focused. They could have all been here, but 2 of them are in a Sri Lanka, so because they can't come to New Zealand at the moment. So the time zone for them is like 3 in the morning at the moment, or 4 in the morning. So 2 days in a row, that's probably going to not be very nice on their lifestyle. So maybe if we're going to add some notes just to get you guys to do something, because I know that some of you, it's quite late, and well, I guess it's what, 8 o'clock in the East Coast?
Reaching 6 p.m.
Oh, yeah. Okay, so you're still there. It's dinner time, so yeah, so we'll be finished.
Almost dinner time. Yes, getting a little hungry, but.
And I'm going to jump out to the other breakout room just because I like to hear the other thoughts about remote collaboration. So,
well, maybe before you go, maybe you could summarize, if the 3 of you could summarize your notes for that work.
Okay.
That. Yeah, because we're going to hear from all.
Sure, I did.
There's
I did post something on Slack.
Yeah, the remote. Oh, did you put it in the general or did you put it in the?
Oh, I guess I put it in the general. I don't know. I put it below, underneath what Joaquin had put. Because...
Oh yeah, he put it in the wrong spot. He doesn't listen sometimes.
Oh, sorry. I didn't. Yeah, I don't know if I saw.
You have to join
other channels.
Yeah, if you join the other, there's 5 channels there. Well, there's a whole bunch.
Well, I only see 3. That's the thing. I only see general, random, and research.
I also only see 3.
Yeah, same here.
Ah, okay. Why don't I add you to that surgery channel then? You should be able to see that. I can just. You can add.
We have to click on all channels and then we have to join. So it's.
Yeah. Slack has a weird way of doing it. I can't see what people see, so and
research topics.
Yeah, there you go. You should be all there now.
Yeah, now I see that.
You might be able to see the other ones too. I'll add you to a bunch of them. I can't do that thing. All those. Yeah, there's too much overhead with these kinds of things. Yeah. All right. Okay. Cool. Yeah, so we'll wrap up in a couple of minutes because I think that's probably what's better to do. I think some of the groups are dwindling. People are starting to get tired. 4 hours on Zoom is not much fun. And then, unfortunately, we had a last-minute change that they asked us to do Zoom on the other thing, and I'm like, well, I'd planned this weeks ago. Now it works really well on the setup that we had, and half the people couldn't find the Zoom link to get it connected, so it was not a bit challenging. So I guess the surgery things, I guess maybe I could add something since I made a comment, making software generic to switch between different medical surgery focused application, something like that. Oh yeah. So my comment's probably similar to Regis, but more focusing on the software side of things. Cool. All right. Well, I'm going to bounce it around to the other 2 rooms just to get them known, and I'll shut the rooms down for 12 o'clock, and we just come back to the main room, and maybe Sarah or Regis, maybe Simon could summarize what you've discussed briefly. It doesn't have to be in detail. Just 1 to 2 minutes would be fine. Okay. Does that sound like a plan?
Yep.
Yeah. Cool.
Sounds great. Thank you.
No worries.
collaboration, we need a server, client server architecture. So the server hosts the session, or let's say the network session, and the other could join together.
I think we can use like a hybrid approach like torrent, which you have like one tracking and then you do a hole punching there. And that's how you can get a peer-to-peer network. I'm not sure, I'm not a specialist in computer network or infrastructure, but that's what my speculation would be. And it's tricky to say how we can protect data and so on, because it really it's within the hand of the developer, not within the hand of the user, and the user doesn't know what's going on inside. And I think this applies to other fields as well, not only in XR. Yeah, I'm not sure. But anyway, we can put it there, data protection.
Cool. So if you can add your notes into the Slack channel, and I'll shut the rooms for 12 o'clock. And if we just come back at 12, we can do a wrap up of what each of the rooms stated or talked about.
We have a question regarding future research areas, something that you mentioned. So what it's about?
So yeah, there's basically, there was another breakout room if you wanted to talk about research topics for beyond here. So rather than what everyone's currently doing,
I see.
What would you do in the future? And I believe you and Kaiming are both PhD students. I don't know, Maximilian, are you a PhD student or an academic?
Yes, I'm a PhD student.
Okay, so the three of you are PhD students. So, you know, I think you're all working on your existing projects, but you have a life after this. And it's like get a postdoc or an industry job or do your own company. Those seem to be like the three options that most people take. Or, you know, go do another degree. But I somehow doubt that no one wants to do another degree after a PhD. Were the three of you at the doctoral symposium yesterday? Did any of you attend the doctoral colloquium?
No, I wasn't.
There was a session there for PhD students to attend. You have to write a 2-pager and submit it. And there was like 20 students that were attending that. So I had 5 students in my group that were attending that, and a couple of them were here this morning, but then they're a bit tired to do 2 days of all-day Zoom. So they said, I'll go to the conference on Monday. They wanted 1 day off for the weekend. And 2 of them are in a completely different time zone. Like they're living in Sri Lanka, and I think you guys are, whereabouts are you all? You're in which countries and cities? Without me having to look.
I'm in Magdeburg in Germany.
Magdeburg?
Magdeburg.
Yeah, Magdeburg, yeah. How about you, Kaiman and Maximilian? Where are you?
Munich.
I mean, that's right. Okay, so 2 in Germany. And where are you, Kaiman?
I'm in Leuven, Belgium.
Oh, right, that's right. Okay, yeah. So you guys are in, you know, beautiful parts of the world. So yeah, well, you guys should meet up at some stage or something. I guess to answer your question, future topics, the plan is to probably do another workshop like this, potentially at Kai or something. Not this year because we've missed the but maybe next year, something like that, or VR. Yeah. So we're looking to do a series of events like this, and so yeah, we'd welcome more submissions. And the idea is that, you know, coming to these kinds of workshops is to increase your research capabilities and turn your ideas into research papers, and you can reach out to, you know, others in the community here, such as the other academics, to understand what's going on. Like you're all new to research. I don't know if that's the case, but that's the general assumption of a PhD student. And at the LMU, who are you working with there? Andreas Butt or Albert Schmidt or somebody? Maximilian at LMU.
No, I'm not at the LMU. It's a technical university.
Sorry, TUM. Who are you working with there?
Yes, I'm working with Hospital Rechts der Isar, it's called, also with a MRI, and also part of the LMU, but I'm working with them since 2 or 3 years. I had some projects maybe for dialysis training, and the ECMO was more a weekend project, and some other projects. So we're it makes fun with them. It's a good collaboration.
Okay, I'm just going to close the breakout room. So if you finalize your notes and then come, it takes about a minute for the breakout rooms to close. So thank you for your efforts in discussing and coming along today. And it's midnight for you guys now, right?
Hosting this.
Yeah, it's 12 now.
All right, so I know you want to go to bed, so we'll do that. Okay. So then I'll close all rooms and it takes about a minute. There you go. They're starting to leave now. So I'll see you in back in the main room.
I think you got my point.
That was jarring.
Hello, Craig. Are we playing Survivor here? And you're in mute.
Sorry. I'm not the one that I woke up and had a decent sleep. So you're all champions. Most of you are in Europe, I think. So well done.
It's 11 p.m. here.
Yeah.
And it's midnight where in Central Europe.
Yes, exactly.
It's 12 here.
Denmark and Italy and France. And it's 6 p.m. somewhere in North Carolina.
There's a couple in North Carolina. All right.
I'm really.
You have bridges there.
Go for it, Simon Kohler.
No, I just want to say I'm really glad you didn't schedule the workshop for afternoon, because that would have been in the morning for me, 3 o'clock or 2 o'clock.
We were originally, but we actually advocated for being in the morning due to the time zone. So thank you. So just to wrap up, it's midnight for a whole, or midnight or 11 p.m. if you're on the Portuguese/UK time zone. Thank you very much for coming. So if we could just hear from each of the rooms for a couple of minutes, and if one person, there was 3 rooms that we had where people actually participated: the training, education, remote collaboration, and the surgery rehab. I think there's somebody from each of those groups. So maybe we'll start with the training education. If you wanted to say 1 or 2 minutes. And if you put the notes into the Slack so other people can read the notes, that would be really great, or any links or anything like that. So go for it.
Maybe in the chat here as well. I don't have Slack. That would be great.
Oh, do you want to join Slack?
I never use it.
Okay.
I think it's fine. It would enough to just post them in the chat here.
I have put some notes in Discord, Craig. But anyway,
Sure.
there are some.
Okay. I'm not looking at the Discord, but okay. If you are speaking, maybe you just copy your notes into the chat for the Zoom so others can see would be good. So I'm handed over to Maximilian and Vuthia, and who was the other one? Kaiming, who was in the training education. One of you want to speak about your room?
Okay, I can wrap up. No, summarize what we discussed earlier. So we identified 5 challenges in VR in education or training setting. The first being the policy. Basically, it relates to the flexibility of the legal and policy system in the context of deployment, which also branch out to the second point, is how ready are we to be taught by machine in that case, or like fully a fully automated system without human in the loop. The third point being the bridge between the expectation of the user and the reality of the job, because there are many cases in which we find that the user or the participant, they expect game full of fun things from VR or something that provides explicit feedback, while in reality, it doesn't work that way. So there wouldn't be marker or label overlay on the surgery procedure, while in VR, we have these sort of things like tutorial. The fourth point being the context of evaluation. Basically, it's hard to conduct a large-scale study to draw the effectiveness of VR in training with respect to the clinical outcome. How do we compare these things? And it's hard to run a large-scale study considering that the legal and policy system doesn't really enable that. And our last point of discussion was the risk of conveying misleading image of the practical task, which is related to one of the points we mentioned earlier. Basically, the simulated experience can be more of a subset or a simplified version of reality. But in reality, it's way more complicated and more challenging. And what they learn in simulation doesn't always translate to a correct knowledge in reality. And that's what we discussed earlier. Thank you.
Oh, thank you very much, Kaiming. All right, group number 2. So that's Helena and Joachim and others. So maybe Helena or Joachim don't want to go. Maybe somebody else wants to go, but I'll let you guys. Remote collaboration. Whoever wants to go. For it.
I'm happy to read the things that I wrote. A few times that I went to the Slack and I was like, I'll capture this. So we started our conversation talking about when XR is deployed in the home. We were sort of reflecting on Deborah's talk earlier on in the day. And one of the things that came up, we're talking about different environmental constraints that come into play when you're talking about the local collaborator being in a home. So you've got space, clutter, privacy concerns that could come up. Internet access is always a big question among a bunch of others. And so it really kind of, the conversation sort of, I pointed out that like, even though I understand that the idea sometimes is to see what we can learn when we can put together these ideas and just try them out. If we start not realizing that like 90% of the world lives in certain, like not the 1%ers living conditions, and that these are like really pervasive concerns to keep in mind, especially with the population that they were talking about, that it kind of maybe it does affect the design of the system, and it should be thought about up front. Let's see. So Craig popped in and the question was, what are some of the affordances of AR VR for collaboration? And we did discuss that one of the affordances is that you can record, like we're doing now, when you're in an AR VR environment that's not just a face-to-face, non-technologically enhanced environment. And then we kind of were finishing our conversation when we got cut off there about using, especially for long procedures that you don't want an expert just sitting there and just watching, because we were talking about how we actually like the 3-minute talks because you kept your attention. So then we were talking about like, how can you capitalize on eye tracking or AI or some type of machine vision to bring in the expert when they're needed and not just having them always be available. What else would I ask?
Yeah, we discussed the affordances of things that you can do in AR, VR that you cannot do in real life. That was the other thing about, and the pandemic has forced remote collaboration on us, but that's commonplace. And yes, the idea that artificial intelligence or machine learning could help people in making them aware that they are making mistakes, especially when fatigue sets in.
Cool. All right. Thank you, remote collaboration team. That was really good. Anyone else from that group that wanted to add beyond Helena or Joachim?
We collaborated a lot.
Remotely. Okay, all right. The third group was the medical and surgery group, which had Sarah Regis, Simon, and I popped in for a bit. So Sarah or Regis, do you want to make some comments there?
Sure. Yeah. Do you wanna say something, or do you wanna take it on, Sarah?
I can add more after you.
Okay.
Yeah.
Yeah. So we talked about I think challenges of the one thing that you brought up, Craig, was whether we could generalize specific techniques for surgery, for example, that or for surgery support that are designed to certain certain types of surgery to other types of surgery. We talked about how the general concept applies, but a lot of times there are specific challenges, not so much in terms of software per se of the like VR or AR software, but image processing, and there are also challenges, I think, depending on the different parts of the body that are being operated on. If organs are more dynamic and deformable, it's also more challenging. I think we also talked about what was it? Help me out here, Sarah.
We've talked about one of the challenges, such as, like accuracy in surgical application, which is gotta be super, sub-millimeter accuracy of, hologram alignments for AR application, for example, or other things like reliability of the system, such as, jitter or like network latency for both AR and VR. Those are quite crucial like factors for the implementation of AR VR in a clinical settings.
Okay, yeah, I heard some of that when I was there. Okay, any other comments from anybody else?
I think there was one theme that kind of overlapped between all groups. It was with the network latency and so on. So that's probably one of the major challenge for all of us, not only for education or anything. It's also for surgery and CSCW team as well.
And I think some people are working on generically XR for Zoom equivalent. That's the project I like to say, because I've got a student working on that, so I just call it the XR for Zoom project. But that is something that we could just rely on the network community just to solve the problems for us. But is there a way that we could actually do something better from the XR/health space? I don't know. But yeah, that's I think a really good comment. The software underlying technology stack. Yeah, that's. So without further ado, maybe I'll share my screen and I'll talk about a couple of closing things. And if my colleagues want to say anything, my other conspirators want to say anything, they're welcome to as well. So I thought about talking about the next steps and where we would go for this workshop. But first of all, thank you very much, everyone, for participating and being here for the whole 4.5 hours. I know it's not easy, especially the late night time. So some of the things we've thought about as the organizers may be doing another workshop as part of a workshop series. And one of the proposals was to maybe do something for Kai next year, which would be in about 12 months time from now, sort of May 2023. I don't know where even, the website I'm sure tells me where 2023 version is, but I haven't actually looked in the last couple of weeks. So I'm sure one of you knows. There will probably maybe not.
Hamburg.
What's that?
Hamburg. That's where Kai 2023 is going to be.
Right, so that might be a nice location, especially there's quite a few Europeans on the call. The other option is VR next year. I don't know where that is.
China.
Right. See, there's somebody that knows in this crowd. VRSP is another option as well. So, or potentially a health conference. What would people's gut feelings be if you would want to meet again in this kind of format? Not necessarily a Zoom thing, but a format of these kinds of people. Just fire some ideas around if you have any.
Yeah, I think it would be nice to repeat the experience. Maybe Kai next year. Maybe SIGGRAPH.
Right, yeah, you mentioned cigarettes too, right? So I had that as well. I guess so in the audience here, are most people HCI researchers, VR researchers, which some people like to say there is a difference. Health researchers, I mean, we've seen a bit of everything, I think, but for the people that are here now, what would you see yourself as?
I'm more of a VR researcher.
Who's HCI?
Like HCI.
I'm HCI.
Okay.
HCI.
HCI, AR.
Yeah, HCI, VR, same as Bridges.
Is there any health people that just are focused on health and then looking at how to use VR? There were a couple of people like that during the workshop.
Yeah, we had a couple.
Yeah. And then how many people would say digital health within the HCI is their core area? Because I know we do lots of other things.
What was that? Digital health within HCI? Is that what it said?
Yeah, that's the question. Yeah.
Yeah.
Kind of. Yes.
And there's some PhD students.
Rarely do I go elsewhere.
Cool. Okay. Well, if you've got comments or questions about another workshop, feel free to send an email to the organisers, and we will work on something like that. And maybe it's not necessarily these organisers. We may ask other people to help us out, and we'll come back to people on the Slack channel at some point. But the Slack channel will still remain. I guess future publications. So one comment was, Joachim runs a journal called Computer Graphics and Applications, I think it's what it's called. So there may be an option to be able to do a special edition there of some papers in that context. I think I forgot to also plug the digital anatomy book. So let me just bring that up.
Oh yeah, you definitely forgot to plug that one up. Yeah.
Yeah, so Joachim and others, mainly from Portugal, created this digital anatomy book. And that was released a little bit earlier this year. So some of us have chapters in that. Sorry, last year. I started to lose track of when it was. Yeah. I'll put that in the chat window. Where's my chat thingy gone? And I'll put it on Slack. So yeah, so there's a potential option to do something like that again. And people could submit chapters on some of their projects. It's probably pretty good for PhD students, and obviously academics that have got PhD students. It's a nice collection of books. So we are not committed to that, but that's one option. Is one of the things that we could suggest is another digital.
It's not CG&A, by the way, Greg. It's CNG.
CNG. I'm sorry.
Yes. Yeah.
Computer graphics. Yeah, I'm a bit tired. You're more tired than me.
Okay.
So yeah, just looking at other options, and yeah, or the other option is
Springer book could be a more ambitious project. Yeah.
Say that again.
It could be a more ambitious project. I still remember the work that we had to put into the digital anatomy. Maybe it would be something like XR for health. But, it would be nice to repeat the workshop next year or later this year. I don't know.
Yeah.
But yeah, Kai 23 might be a good one. That's about 12 months from now.
Yeah. And then I guess, one of the things that we wanted to do is we heard a lot of problems and a lot of issues and a lot of different techniques and so on, but maybe come up with some kind of manifesto that sits around using digital technology to help support healthcare and wellbeing. Focusing specifically on XR might be something that we could work towards as a community, whether that comes out through the workshops or something else. But I think, sounds like most people are interested in doing it, but the question is actually doing it. That's always the conundrum with these kinds of things. So we're open. But yeah, so I will ask Helena and Joachim if you want to add anything as organisers to this slide. Anything else?
I mean, I threw something in the chat that, when we first started talking about this, I was like, are there that many people out there who do XR in healthcare? And I was like blown away by the number of folks and the really interesting stuff and how much overlap. So I would say that, first of all, I hope everybody got something out of this, but also that keep doing it because it is actually really important. And yeah, we definitely need to continue to ensure that we're building a community of reviewers. I now know who I'm going to ask to review papers for me. But hopefully also collaborators. And I like the idea of the manifesto as well, but stay in touch.
JJ?
I like the manifesto idea. Yeah, it's like the next thing that we could do. And yeah, I'd be happy to co-organize a workshop next year, I think. And if there are any takers, I would be happy to entertain the special section on extended reality for health applications. Maybe some of the people here would like to take on that effort. I know that Mark also suggested. Maybe I'm looking at Regis. That's something that you might want to entertain next sabbatical.
Absolutely. Yeah, I'm looking forward to it.
Cool. And I guess I can do one final plug. So if you want to come to New Zealand, I'm running a small little conference called ACM ISS, which is Interactive Surfaces and Spaces. So it's actually in my hometown of Wellington. So it's in November, and the paper submissions are in July. And so it used to be called the Tabletop Conference. And
ITS, Interactive Tabletops and Surfaces.
Yeah, so it basically does focus on VR. I think that's the link there. I'll just put it in. I have to fix up some URL stuff. Oops. Yeah, there you go. It just redirects to something else. If you go there on the chat. So we basically are looking, it's following Packham model. So it's the journal version of the HCI thing that they've set up. And we've had one round that just closed a couple of days ago, about 2 weeks ago, I think, on the 28th of Feb, but there's another round in July, and we'll have like doctoral symposium posters and so on due like late August, early September. So if you're working on the summer, I've got a project, it'd be a great thing to do. A couple of other events that we're doing, we'll have the local HCI New Zealand conference, co-locators, but that's not a lot of people. We only have 5 million in the country itself, so you can do the numbers. But we also plan to have a masterclass around this space. One of the masterclasses, summer schools that we've done in the past, is known as this XR workshop thingy. So if you just change the URL to say XR workshop, and so if you go there to this workshop page there, just same as the XR Health, but just change it to the word XR workshop. Myself, along with Mark and Joachim, and another colleague, Rob Lindemann at the HIT Lab in Christchurch, have been running a workshop. It's basically a summer school. I wrote the workshop, but it's a 4-day summer school on XR technologies, and we've had 2 editions of it, 2020, just before the pandemic hit, like literally a few weeks. And then we had one last year in February, and we were planning to have one last week in Christchurch, but unfortunately the pandemic put a stop to that. But we will have another one later, either this year at ISS or sometime early next year in Christchurch. So you'll be welcome to join. The first one we had about 65 students attend, and they were mainly New Zealand and Australian students. And the second one we had only New Zealand students, but we had Australian students from about 5 or 6 different cities joining in remotely. And we had a couple of students joining in from Europe, but it was New Zealand time zone. So that's quite prohibitive for people in Europe to attend. So but if you are interested and want to join, you can join remotely. Just send me an email when we do things. Otherwise, there'll be some funding for a limited number of funding to get students there. Obviously not academics, but students. It's a workshop how to learn about XR technologies. So if you're quite enamored in how to do that already, it's probably not for you, but we do have a strong focus on learning, doing stuff, and students come there and they work on a project, and we have a bunch of speakers, typically local ones, but we also have a few international people, and you can see we've had people from Facebook, Unity, and a few other places. Hopefully we're getting some people from Unreal for the next event. So yeah, that's just sort of a couple of other plugs I have. And I didn't want to publicize them too much, but you're welcome to have a look. Right. Does anyone have any other parting thoughts before you go to sleep, most of you? And
I would like to see the manifesto happening. I think it's a nice idea for an exercise in collaborative, creative writing.
Cool. And that might be, you know, maybe a CACM article or something like that, which would be typically these kinds of things go.
Grand challenges / manifesto, yeah?
Yeah. Cool. Well, if not, I know it's late for most people, but I'd just like to say thank you on behalf of the other organisers. Mark's had to shoot off to the Health and Safety Workshop, but on behalf of Helena, Joachim and Mark and others that all contributed, so thank you very much for all your efforts. And I will be about during this week if you want to reach out or reach out to any of us. We'd be most happy to have you. And I think the main point is we want to be an inclusive group, so we're not exclusive. So, you know, it's the best efforts approach, and we're sorry that there was some YouTube Zoom link issues at the beginning, but we did our best. So thank you for your attendance, and ka kite anō, which means goodbye in Māori, and have a good day. And I will
Thank you, and goodbye.
Nice time.
Bye, everyone.